this meeting and Earth systems. I extend my warm welcome to each and every one of you. Our meeting today is graced by the presence of distinguished scholars, and I am delighted to introduce them. We have with us Professor V. Krishnan, the former president of JNCASR Bangalore, and the coordinator of TWAS-CASAREP, our renowned geologist, Professor B.N. Upreti, a TWAS fellow from NAST, and the coordinator of this event, Professor Pramod Jha from NAST. And we are also honored to have Professor Gio Kulkarni, the president of JNCASR Bangalore, a well-known figure in the field of inorganic chemistry. Today's program promise a wealth of knowledge with 10 lectures scheduled, including 1 keynote address and 3 invited lectures. So I would like to take this moment to extend a warm welcome to our keynote speaker for today's meeting, Dr. Madan Lal Shrestha from Nepal Academy of Sciences and Science and Technology, and representative to World Meteorological Organization, Nepal. We are also privileged to have our invited speakers, Dr. C.N. Prabhu, Joint Director of Bihar Mausam Seva Kendra, Professor Abdul Harun Chaudhary, Professor and Head Environmental Sciences, Khulna University, Bangladesh, the esteemed geoscientist, Professor V.C. Tiwari from Sikkim University, and Dr. Parminder Ranhotra, a senior scientist from Birbal Sahani Institute of Paleobotany, Lucknow, India. Without further delay, I would like to invite Professor B.N. Upreti to chair the first session of today's meeting. Thank you all for being here, and I look forward to a day of insightful discussions and knowledge sharing. Professor Upreti, the floor is all yours now. Thank you.
Thank you, Jayshriji. Now we start the session 3 of today, 2nd November 2023. We have 6 presentations for this session. And the first one is the keynote speech. And the keynote speaker today is our Madan Lal Shrestha, academician of NAST, already was a little bit introduced by Jayshriji, but I would like to read a little bit more about Professor Madan Lal Shrestha. He's an academician of Nepal Academy of Science and Technology, NAST, with a degree in meteorology from University of Hawaii, USA. He served as the Director General of the Department of Hydrology and Meteorology, Nepal, and he has been the permanent representative of Nepal to World Meteorological Organization, WMO. He has been the focal point of Nepal to Intergovernmental Panel on Climate Change, IPCC, and contributed to the World Group 2 of the 3rd assessment report of the IPCC in producing the publication Climate Change 2001. Impact, adaptation, and vulnerability. He is the first Nepali to join glaciological expedition of Nepal, the first joint scientific expedition between Nepal and Japan to explore the snow and glaciers of central Nepal Himalaya. He contributed towards the preparation of initial national communications as well as the 3rd national communication to be submitted to UNFCCC from Nepal. He is the Scientific Planning Group member of Asia Pacific Network for Global Change Research, represented in Nepal. He had been the visiting professor of Nagoya University and also at Tribhuvan University. He is the member of the advisory board of Journal Scientific World, Nepal, and Journal of Meteorology, Pakistan. His fields of research are the meteorology, climate variability, climate change, and climate change. He has published many research papers in peer-reviewed journals. So I invite Dr. Madan Lal Shrestha to deliver his keynote speech. Thank you.
Thank you, Professor Upreti, the chair. Actually, I'm very much privileged to present this small talk. And I thank the organizing committee for giving me this opportunity. I would like to look at the climate change aspect from the global to regional and also to very much at a country scale. So I will just run through these things. And with that, I was looking at, is it not coming? Sharing?
Share the screen.
I already did. Okay. So how is the sound? Is it okay? Okay. So I think, look at the recent, the assessment, the sixth recent assessment on this climate change, the IPCC. I was really, I like this, slide. And before we used to talk about the warming of the warming train like that, but nowadays, if you look at the title, we are talking about hot extremes, because the warming is unequivocal. It has been from the third assessment, and during the third assessment, we had a very hard time in keeping the cryosphere into the climate change aspect. So we really did a good exercise. And coming to now the recent assessment, I think we can see that, this cryosphere aspect is coming up very, very nicely. And so when you look at this, if we divide the whole globe into 45 regions, in 41 regions, the hot extremes, it's not at warming trend, it's the hot extremes has been increasing in 41 regional, the regions. And there is no regions where the temperature is decreasing or the hot extreme is there. So every places we see this extreme warming situations, and that is very, very significant. That means to say that the human contribution to these hot extremes is very significant. And so it's very high. And likewise in the precipitation, because when we talk about the climate, normally we usually take precipitation and the temperature. And the temperature is behaving very, very significantly, whereas the precipitation, though we don't see any decrease throughout the region, we don't see any decrease. It is increasing, but the confidence of the human contribution is almost like a medium kind of a thing. So I was looking at the recently, if we talk about this, if we look the last August, now we are in November. In the last August, when we look at the global air surface temperature, we have this 2023 is very much unprecedented. You can look at this. It is 0.71 degrees Celsius above the average. When we take the average, it is 1991 to 2020. Normally, from the World Meteorological Organization, we talk about this 30-year average. So above that, so it is very, very significant. And if we look at the temperature, in the first picture, the temperature. If we look at the 1850 to 1900, the water bodies and the land, there is not much change. But slowly after 1900, it started to diverge, and now it is very significantly different. That means the landmass is warming very, very rapidly than the ocean mass. And when we talk about the whole globe, it is about 0.1 degrees Celsius per decade. And these data are from the ERA 5, that means the fifth generation of the reanalysis data from the ECMWF, the European Centre for Medium Range Weather Forecast. So that is one of the, I think, the leading organization in the world having, these forecasts as well as generating these data. And, in the second one, the annual one, definitely it is rising. And if you look at it, the picture from 1970s, it started to rise. Before that, you don't see that much of significant rise, but after that, and if you look at the third diagram, the last 4 decades are the warmest, the decade. If you go back up to 1852. So I think this kind of very much warming in the recent decades is very, very prominent. And when you look at it, if you put these warm, the warm years, and we are taking this in the boreal summers, that means in the northern hemisphere, whole northern hemisphere, if we talk, the summer temperature, 2023 is much more significant. This is for the summer month, June, July, and August. And if we try to look at this picture, what we see that, there are 30 warmest. This is for 30, and these are in the ranking order, not air-wise, but in the ranking order. So 2023 happens to be in the number 1. And if you look at this, if you look at 1997 to 2000, in 14 years, the warmest year are 7 years. But if you look at this, the beginning of this century, from 2001 to 2023, in 23 years, all 23 years are the warmest. And that's why I think from the previous diagram also, we saw that the last 4 decades are the warmest. And this is very much, the alarming in the sense, I think, which I think we'll talk about a little bit later. And when we talk about the climate change, just having the surface temperature or surface temperature is not enough. How the Earth, atmosphere, and the ocean is interacting each other, because there is a very close link between the atmosphere and the ocean. So the state of ocean is also very important. And if we look at the 31st August 2023, that is the highest temperature that has ever been recorded. So I think the 2023 is building. And if you look at this, the lowest one, the blue one, is the 70s. Slowly, all the records are slowly increasing, and it is very, very significant, very significant. And this, this light red line is 2016. Till today, 2016 is the warmest year. But if we look at 2023, we are in our data. We did the data up to August. So during that 8 months, the temperature difference between is just, the 0.1 degree difference. So I think, so that is why, this temperature of the ocean is increasing very, very fast too. And in this one, another thing we have to remember that, we can conject, you can also argue that this is not the normal natural one, because at this time we have El Nino. Warming of the Pacific is at the peak. So that is one of the contribution that is happening. And this El Nino, what we are talking, and if we talk about the role of El Nino, that it has definitely a very detrimental role in the precipitation. So when we have El Nino, normally South Asia and including Nepal, we have a lesser precipitations, because I think I did some study in 2000, so it is already low. So I think we have to revise in Nepal. So we have very significant less rainfall that we received during the El Nino period. So I think if you look at so when we talk about the climate change. We are, when we go to the Paris Agreement and UNFCCC, all the politicians, everybody talking about, okay, let us keep it 1.5 degrees Celsius. Let's not increase. But that 1.5 degrees Celsius is going to be reached in 2034. If the present trend of the warming continues, but looking at the warming rate, the warming rate is getting much higher and higher. That means even before 2034, we might be reaching 1.5. That means it looks like, I think, there is a big gap between the scientific community and the policymakers. Policymakers are always talking about this one, but not doing. And they are not listening to the scientific community. So that kind of gap between this is very much evident. And if we look at the, if we look at this, the Paris Agreement, they also say, okay, don't let it go above 2 degrees Celsius, and they try to stay in 1.5. That, I think, seems to be not a, the possible scenario looking at the present warming rate. And that's why, I mean, the scientific evidence is overwhelming. We will continue to see more climate recurs and more intense and frequent extreme weather events impacting society and ecosystems until we stop emitting greenhouse gases. This minimizing the emission of the greenhouse gases has been the hot topic in all the, the conference of parties or IPCC or WMO everywhere, but nothing is happening. And if we talk about the, what will happen after 2100, because we thought that, 2034, it will be 1.5 degrees Celsius, already it will reach. But if we take, this IPCC assessment, they slice into 20-20-year period. And if we look at the 2100, even the middle one, this SSP2 scenario, this IPCC's, the scenario has been changing a lot. There is a lot, the evolution is very, very significant. Now, SSP means shared socio-economic pathways. Before we have the RCP, representative consultative pathways. So, and before that, we have A1, B1, something like. So there is a lot of evolution that has been going on. And they try to include as much as possible the effect by which the greenhouse gas is increasing. And if we look at 2100, it is, even the median one is 2007. And even the up to 60, it is 2.0. Okay. So I think in that way, looks like the goal that we have set, the scientific community were worried about, is not going to meet. So the, we talk of the Paris Agreement 2015 was a huge success, no doubt about that one. Everybody, agreed that, okay, let us review, the progress of this GHG emission, because we have to control, we have to curtail the rise in the global average near surface temperature. But if we look at, this is the one that has been said in the Paris Agreement. And in Paris Agreement, the decision makers, most of them are the policy makers. And if we look at the scientific side, see, this is the carbon dioxide, and this is methane, and this is nitrous oxide. All are very significant GHG, which is responsible for the warming of the globe. And there is no sign in any change. If you look at the chlorofluorocarbon, that has been already curtailed. So you can see the downside, but here, carbon dioxide, methane, and nitrous oxide, there is no downward trend at all. And as much as it is increasing, if you look at the methane, that is very, it is 21 times stronger than the carbon dioxide. The rate is much higher. So, one thing that we said in 2015, and what is happening in the atmosphere really is very, very different. So that is a little bit worrying thing. So this is in the global side, we have this kind of a picture. There's some kind of a gap between the science and the policy. And that was the global picture that we saw. But when we come to the regional, if we come to the Asia, one thing in this one, the one significant thing is, as we go to the northern region, the cooler region, the warming rate is more. This rate means more. So the warming rate is more. And the analogy to that one, if we talk about the temperature if we talk about the topography, like in Himalayas, as we go up, the warming trend is becoming much more. That is, in the cooler, when you have a cooler atmosphere, then the warming is much more. And that is a worrisome picture for the Asia. Because if you look at that, this the rise in temperature, this one is very, very steady, and it is increasing much faster. And that is so, and this is the interesting fact is, there are 6 data sets in this graph, and these 6 data sets are very much, they are telling you the same story. So that means there is such a huge confidence in having this kind of a temperature increase. And if we look at this, because the impact of that kind of the change, if we look at in the Hindu Kush region, because it is the whole Asia, then now we come to a little bit concentrated, focused into the Hindu Kush area. And that is a very, the important region. Most of the large rivers in Asia are
2 minutes.
Okay, generated in this one. So in this region, if we look at it, this red triangle, upward red triangle is increasing. So almost everywhere, the temperature is increasing in the Hindu Kush region. And at the same thing, the first one, the red is increasing in Nepal. If we look at it, as we go to the Himalaya, higher reaches, the temperature, the rate of temperature is much more. And now, there is many impacts of the climate change. If we look at the glaciers, and that is a very good indicator of the climate change. And this is the global one. In the global one, it is decreasing like anything. The decreasing means in 65 years, the thickness of almost 34 to 35 meters has decreased in 65 years. So, and that trend is going to continue if the warming is there. And then the same thing happens in the Himalayan and the Tibetan, the China and this Himalayan region. It is decreasing. And I wanted to share this one. This is the glaciers we call the Rikha-Samba Glacier in the central part of Nepal, behind the Dhaulagiri Massif. And this is the photo we took in 1974 when I joined this Nepal-Japan expedition to explore the glaciers and environmental conditions in that region. And this is we call the Hidden Valley. The base is about 5,050 meters. That is where we had this camp. And this is the 1974 to 1994. After 20 years, the same glacier has been monitored, and this is the condition. Then in the 2010, we have the last one. The whole snout of the glaciers has vanished. And this time also, I tried to get the picture because recently there was a survey of this same glacier. I couldn't get it. But the main thing is the glaciers are retreating pretty fast. And now there is a continuous glacier monitoring is going on in the Everest region. We had the Changrinuk glaciers, Pokalde, and Mera glaciers. And in all these glaciers, again, the decreasing is very, very significant. The loss of ice mass is very significant. And recently we have the expedition that is going on in the Humla, and this is a very recent one. And let me just 1 minute. And so the extreme, the effect of the climate change is not only the decrease of the glacier mass, and that may be the one of the reason, because in that one we have the growth phenomena from the glacial lakes. Then another is heavy precipitation and flooding. Then we have a drought and heat waves and forest fires. That we have seeing not only in this Asia, but all over the world. And so its impact is in the loss of life and the loss of property, as well as in the economy and the food system. So the one thing here I wanted to mention, this is the when we wanted to look at the greenhouse gas, we look at the bottom-up approach, what is happening in the grassroots level, then we estimate. And it says that it does not work well in the developing countries. This is the IPCC thing. Definitely, I think that is the case. Normally in the developing countries, they don't have institutionalized monitoring of GHGs. They don't have. Every 2 or 3 years, when you have to submit to the FCCC, they go on bidding or something like that. So somebody get it and somebody put the report. So there is no, but unlike the developed countries, and because of that, this kind of statement is there, and which I think as a developing country, we don't want to see that. So I think we need to have some kind of the institutionalization of this status to monitor the status of the GHG. So this is all that I have to say. But one thing, yesterday I was listening to our Tiwari and Basanta about the data. And I would like to, because recently we published in 2023, a few months back, we published a paper. And that was, we produced a 5-kilometer grid data of temperature and precipitations. So I want especially I think we have the young scientists here. So I want them to use this one and give us the feedback. And this is available. So if anybody is interested, you can go through the APN site also. If not, you can contact. And the same way, there is up-to-date data. It is also 25 kilometers is available in the web, but the 5-kilometer data, I think you can contact the Department of Hydrology and Meteorology. If not, you can contact me. So we can supply those data, because these data, what we generated, we wanted to see it in use and see that how can we fine tune our models to generate these grid data. And the last one, this is not an advertisement. Excuse me for this one, because as a member of the Asia Pacific Network for Global Change Research, as a scientific planning group member, there is an opportunity, for the younger scientists, there is an opportunity for the funding. We provide about $45,000 per year, so you can have 2-year or 3-year projects. And now from 10th November, they are launching. So you will see in the website that, and it will be about 1 month, there is a time, so you can put the proposal and you can just Google APN and you get everything in that one. So I think, thank you very much. Sorry for taking a few more minutes.
Yeah.
Thank you.
Thank you so much, Jawaharlal sir, for your exciting presentation and very good data that we have available in terms of climate change research. I'm sorry that we don't have much time. We're already late by 10-15 minutes. So I can have one question from the audience. If you have any, please, yeah. It's not the same question, but I have one. Is there any positive consequence of climate change?
The people, yesterday we saw that there is a positive consequences for the forest, because you can see the tree line is going up, something like that. So I think those who are applying these data, I think they will be able to get positive things in agriculture side also. When you have a carbon dioxide generating, they say, it's bad. But in some plants, that is like a, it's like a boon. So it's good for these plants. So, but one thing is we have to segregate. We have to look at it in a holistic manner, because if you look at the methane gas, which is much stronger than carbon dioxide, one time what the international community said that in Asia they should stop harvesting rice. Because rice harvesting is the main cause for generating this methane gas. And that is why I think from the India and the South Asian countries, they did it by themselves. And the fact is a little bit different from what the international community has said. So I think we have to look in the overall, not concentrating in one, because we can't start harvesting rice. That is why I think it is there.
Okay, thank you so much. Once again, Dr. Madanlal Ji, and I think we should move forward with the next presentation. And we have another very important presentation by a very distinguished scientist from India, Professor C.N. Prabhu, Dr. C.N. Prabhu. The title is The Cause of Flash Floods in Bihar in 2019. I would like to briefly introduce Dr. Prabhu. I guess you are here, right?
Yeah.
Yeah, okay, we can see you. Thank you. Let me just introduce Dr. Prabhu. Dr. C.N. Prabhu, Joint Director Technical at Bihar Mausam Seva Kendra within the Planning and Development Department of the Government of Bihar, is a seasoned expert with 25 years of experience in climate science and hydrometeorological disaster monitoring and mitigation. He holds a master's degree in applied earth science and a PhD in climatology oceanography. Dr. Prabhu's career spans roles in various capacities at different research organizations in India and the European Union. Currently, he is a key figure responsible for technical aspects of Bihar Mausam Seva Kendra. His contributions extend beyond his immediate role as he serves as a member of the expert committee for the establishment of weather data infrastructure in India under the Government of India. Furthermore, he fulfills the role of member secretary of the technical committee for revising the Bihar State Action Plan on Climate Change for the Government of Bihar. Dr. Prabhu is an active member of the Integrated Disaster Risk Management Society and the Geological Society of India. I heartily welcome you, and I invite you to present your presentations. You have 20 minutes for your presentation. Please go ahead. It's over to you. Thank you.
Thank you very much, sir, and thank all the organizers for inviting me for this presentation. And also, I would like to thank Dr. Madan Shrestha. He set the tone, and I take cue from his presentation, excellent presentation. I would like to say one thing. The climate change is happening across the globe in different ways and different intensities. And we see that when we come to a regional scale or local scale, we can see that in a very different form and their implications as such. Today, in my presentation, I would like to show some of the ways of climate change happening in India and part of India where I work at present. Is my screen visible?
If you can make your screen full.
Yeah.
Yeah. Yeah. Perfect. Thank you so much.
Thank you. So I would like to draw your attention to this part of the world where I'm sitting now, and this is what my area of interest is. It is one of the states, densely populated states, where we have, a network of rivers originating from different parts of, the country or part of the catchment is in Nepal and China, especially the Kosi, which often gets flooded because of the water coming from Nepal and getting flooded in Bihar. And that's why this basin is also called as Sorrow of Bihar. But apart from flood, there are various other factors which we have to look into because of geographical challenges, the river system, what we have there, and the urbanization trend, what we see, all that is a factor. But when we look at the hydrometeorological factors, you can see in Bihar, you name any hydrometeorological hazard, it's there in Bihar. Every month, every week, there is one or the other hazard operational in the state. So it is a very pertinent to monitor it carefully so that we can understand what is happening and what is coming in the state, so that we can forecast, alert the people, address the issues, mitigate the impact of these adverse weather conditions. So from January to December, we come across many various hazards. So as I told, urbanization, and that is also adding to this effect. So to address that, what we have done is we have been analyzing the historical data as well. And as a being part of the preparation of state level action plan on climate change, we look into the data very carefully. We see about 60 to 100 days of rainfall in the state, but very few number of very moderate to heavy rainfall events also occur in Bihar. So to monitor it carefully in the current scenario, the prevailing weather condition, what we have done is we have set up a network of weather monitoring stations and all that. We collect very high resolution, both in terms of spatial and temporal resolution data. And we have set up our own forecasting capability in-house. We generate weather forecast, alerts, early warnings, and we also disseminate it through various means to the end users. Why I'm saying this, you will understand little later why I'm giving in these informations to you. This is the kind of network what we have built in the state. In your left panel, you can see the kind of the weather stations we have installed across the state. These weather stations measure temperature, humidity, wind speed, radiation, and including rainfall. It is at roughly around every 100 square kilometer you find a weather station. And the right panel, you see the number of every dot represents a rain gauge station. They're all tipping wicket rain gauges. We measure the precipitation as and when they happen, but continuously every 15 minutes we get the data from all these stations to our network, our database directly. Simultaneously, at real time, they are analyzed, charts, maps, reports generated to understand and also to inform the end users. So, and we take it to the end users through various means like mobile app or weather dashboard, which is a dynamic real-time dashboard you can see. And also we have bulletins we issue for various factors, not only rainfall and temperature. It changes, the bulletin nature of the bulletin changes depending on the season. With this data and the background, I would like to take you to one of the incidents happened in 2019, which was a very devastating flood event happened in Bihar, which affected the life, livelihood, and the lot of property loss, economic loss. All these things happened just one event. It was a very significant event. We analyzed what happened in that event with our data collected through our network. Across the state, we observed moderate to heavy rainfall occurred for over a period of 3 to 5 days. And then some stations also recorded extremely heavy rainfall. See, the network helps us to capture this kind of fine scale information so that we can, delineate what is happening in different parts of the state itself. Because from when we come to global scales, to the regional scale and to the local scale, their implications will be different. That is why we are monitoring to this network. And when you look at a specific, the impact of this event, what we saw there, I take the example of Patna city. There was a urban flood scenario developed in the city, in and around the city. It is mainly for two reasons. One was because of the overhead rainfall, in situ rainfall, which was very heavy rainfall for consistency for more than 3 days, and also a heavy discharge from one of the barrages which is there in the close by area. It is built on the Son River, which the catchment is in the Jharkhand area, and then it flows towards Ganga just before Patna city. And you can see the heavy discharge happen. Apart from the rainfall, in addition to the rainfall, the discharge was more than 2 lakh cusecs during those days. You can imagine the amount of the water added to already the overflowing Ganga channel. This amount of water added to that channel. So the resultant effect was national highway up to about 25 kilometers was submerged, and state highway was submerged, and the rail network was under the water, and the air traffic were disrupted, and the livelihood was standstill. So this kind of rainfall event was very disturbing. And when I came here, I wanted to analyze why did this happen. The question what we put in front of us was why did this happen, and whether we could have prevented this kind of, at least foresee this event so that we can minimize the impact of it. What we did is we started analyzing the atmospheric phenomenon of what happened during that day. We saw heavy rainfall event in that region, not only over Bihar, in the adjoining areas as well, like Eastern Uttar Pradesh, part of Madhya Pradesh, Jharkhand, all that, for a consecutively 3 days or more than that. It was very heavy rainfall also happened. And when we atmospherically we saw what did happen during that time, first factor what we identified was there was a persistent low pressure area in the Indo-Gangetic belt across, persistent it was there. And then when we look at the vorticity at 500 hectopascal, a significant positive value we could see, which is indicative of an atmospheric disturbance happening consistently over that region. One, the low pressure area is happening. There is one atmospheric disturbance as well. That atmospheric disturbance we wanted to investigate much in detail. And when we did that, to do that, we recreated that scenario through a WRF setup. As I mentioned earlier, we have forecasting or the simulation capability we have developed in-house. We tried to recreate that scenario going back in time, and we did that with the same kind of setup and bringing it to 3 kilometer resolution as well, the model setup. Numerical simulations were created with various scenarios, with nudging or without nudging as well. Nudging means ingesting the observed data at different point of the model simulations. What we did see, you can see the result. There was a heavy precipitation did occur starting from Eastern Uttar Pradesh into Bihar, and over Patna as well, it was happening. And when you look at the anomaly, what we observed is it was a very significant anomaly what we observed at that 850 hectopascal for the last comparison to the last 30 years. What we observed is a phenomenon started originating from the Eastern Arabian Sea, traversed across the region and came up to Bihar and connected to that low pressure already persistent. This phenomenon, we tracked it all along, and it was raining. The precipitation was traced across that path, but the maximum rainfall, what was happened, it was over Bihar. So what I would like to convey here is that the vapor transport happened, originated from Arabian Sea, came across the region, and it rained, it translated into precipitation over Bihar, was the reason behind this, the extreme rainfall event, which was very, damaging for the life and property in Bihar. So with this, what I would like to convey to you is, we could have foreseen this had we we had the capacity at that time to monitor it carefully and also forecast it in advance, as we can do now. At that time we didn't have. Now we did this, the postmortem of the analysis after the event. So now we are capable of foreseeing this, any similar event coming in future, so that we can alert the public in advance, at least 5 days in advance or 3 days in advance, so that mitigation measures can be taken in place. A similar event was reported. The similar precipitation event happened over Kerala, and a similar kind of damage was reported there as well. So it is happening. Similar phenomenon is being reported in different parts of the country or different parts of the world. But what we are projecting here is, we will be able to capture these events, or we can foresee these events much in advance, and we can relate to the end users or disaster management authorities, so that they can take necessary measure to mitigate the impact. So the take home message is, yes, the climate change is happening in many parts of the world in different ways and different intensities. To understand that how it is happening at regional scale or local scale, and what would be its impact on that scale, we better have two capabilities: monitor the changing conditions very carefully, and also develop a local or regional scale mechanism to foresee the things. So, and more importantly, take this information, we have to develop a mechanism to take this information to the end users, so that they are well informed in advance with a sufficient lead time. They can take appropriate measures. See, many times the vulnerable community is the first responders themselves. They know how to manage to some extent the initial stages. So by equipping them with this kind of information, they will be able to respond, prepare themselves at individual level or community level. We can tackle the impact of climate change, and we can make a resilient society starting from local scale, and we can contribute that way to the national scale. With that, I would like to say thank you for this opportunity once again. If there are any queries, I would be happy to answer that. Thank you very much.
Thank you, Dr. Prabhu, our invited speaker for this program. I would limit the questions only for 2. And if you have any questions, I can take 2 questions for this presentation. If you have any from the audience online, as well as from the present, those who are present here.
Yeah. Okay.
Sure.
Dr. Prabhu, thank you so much for such an enlightenment knowledge that you shared with us. I'm really surprised to know that we have such kind of systems. And I wonder, do we have these kind of, systems where we are monitoring these atmospheric tsunamis, I should say, very closely in other regions also within India, or it just for this region?
Yeah, thank you, Dr. Jayashree. Yes, I'm very proud to say that, happy to say that this is one of its kind. This is the second state in the country to have such a network. First, it is developed in Karnataka, in which I was involved. And now here in Bihar, we have developed this mechanism. Now the similar setup is being proposed to be set up across the country in India. That is where I'm a member of WINDS committee. Government of India has taken initiative to set up the similar mechanism what Bihar and Karnataka has developed across the country, so that we can monitor the variations in the weather condition, precipitation pattern, and provide services to all the sectors, starting from agriculture and agriculture insurance specifically, and all the disaster management, water resources, and so on. But as of now, Bihar is the second state after Karnataka have a complete network monitoring up to panchayat level, like group of villages. We are monitoring the variations.
Wow, incredible initiation. Thank you so much. Thank you. Thank you.
Thank you. Thank you.
Is there any other questions? So please go ahead. Yeah. Hello, Prabhu. How are you?
Thank you. Thank you, sir. I'm fine. Thank you.
Good to see you after a long time.
Oh, hello, Parvinder.
So I have one question. This year there was an extreme event in Himachal area, if you remember. So how do you link that? Means whether you're this what you showed in 2019 type of circulations, and this year what happened? So is there any similarity, or those were who analyze these two systems? These two this Himachal, Uttarakhand, and that. It's also like, because that time I was also in that Shimla, and they said that whatever amount of precipitation that used to happen in 6 months, it happened in just 4 days.
Yeah. Thank you very much, Dr. Pranidhar. What we have to understand, you look at the part of the year in which the event which I narrated just now happened. It was in end of September, October. We should not get confused with the monsoon circulation, the rainfall happening because of the monsoon circulation. There are various reasons why precipitation happens. It could be monsoon circulation over India, I'm talking, or it could be sometimes because of the western disturbance. That can also bring heavy precipitation. And recently, we are noticing this kind of phenomenon as well. But what happened in Himachal and Uttarakhand this year, I don't think it is anything related to the atmospheric river phenomenon, but it is more to do with the kind of the system developed from in that region, probably because of the western disturbance during that time, and also the monsoon, the strong monsoon activity happened during that time in that region. So whenever we see the heavy precipitation, we also see because of which season it is happening. We cannot consider this can happen in the middle of the monsoon season, because monsoon trough or the monsoon, the jet will be much more stronger than this phenomena, which would not allow. In my opinion, it would not allow that.
That was also in monsoon season, July.
Yeah. And that's what I said. Middle of the monsoon season, and after, at the end of the season happening, they have a totally different nature of atmospheric physics.
Thank you. It will be injustice if I don't give at least one, question from the those who are online. If there is any other question, please go ahead. If there is nothing, then we move forward. Is there any question from the audience from the on the online presence? No? Okay, but anyway, thank you so much. But in the meantime, I was just wondering how many thousands of stations you have in Bihar. And looks like, it's a tremendous task to maintain these stations. Every 10 by 10 square kilometer, 10 by 10 kilometers, that's 100 square kilometers each. How do you find this, and how do you manage these maintenance of these stations? It's not easy job to do that. Yeah, just one quick
Yes,
question.
sir. You are very much right. It's a very tedious task. What we have over a period of time, what we have learned the art of managing this. To be specific, we have about 8,400 drain gauges and about 534 automatic weather stations. That's a lot. That's a lot for the size of Bihar when covering every panchayat. But what we have done is we have automated the entire mechanism of monitoring, evaluating, verifying the consistency of the data, outliers we remove. So that over a period of time, we have learned how to manage that. Most of it is automated. We are a very small team of scientists, group of scientists, about 13, 14 scientists from different backgrounds. We are working in Bihar Mausam Seva Kendra. It's possible.
Yeah, it's
And if somebody wants to do, I'll be happy to help them or assist them in developing a similar mechanism.
Wish we have in Nepal similar, networks. Of course, we have networks, but not as dense as that, and that's what is needed to save lives in Nepal due to landslides and debris flows and floods. This is very important.
And I also take this opportunity to invite you and all the members, to visit Bihar Mausam Seva Kendra whenever it's convenient.
There is one question. I'm sorry, we're getting late, but there is one question on chat box. Where is chat box? Because I'm not opening this one. Did you open? Can you read the question, Pradeep ji? We have not connected to, the online.
So please read the question. Professor Shrestha is going to read the question.
Yeah,
I think this is from Shiva Subedar. That's how often you are losing data because of extreme rainfall or something else.
Okay.
Thank you very much, sir. Actually, losing data means there is there are a couple of possibilities. Because of extreme weather condition, we would lose the transmission connectivity, GPRS connectivity. That is the only way we lose the data. Or other one is if the rain gauge itself gets submerged because of the inundation. Sometimes, in Kosi Basin, the inundation can be up to second floor. So in such scenarios, rain gauge will be submerged. Otherwise, we do, the mechanism is the data is, rainfall is measured. Data logger has the capacity to store the data up to 1 year. So even at that moment, data is not transmitted to our database. Subsequently, we can get the data and database is complete. So very little chances of losing the data. Otherwise, if there is any sensor malfunctioning, we'll identify it on day-to-day basis. We'll ping the service provider. They will go and rectify it. They have a clause. They have to rectify that within 3 days. There are, overall about 2 to 3% of such malfunctioning of sensors comes once in a while. On a quarterly basis. But since we have the dense network, statistically, we will be able to manage that data.
Thank you so much, Dr. Prabhu.
Hope I answered the query. Thank you very much.
You have answered the question. Now we move forward to the next presentation. I hope Dr. Lee is present. Jie Li, China. You're there? Wonderful.
I'm here.
Yeah, that's nice, yeah, okay. I was just wondering if you will be good to connect. So we have the presentation. I hope I correctly pronounce your name, Jiu
Yeah,
Li.
that's right. That's right. Jerry Lee. Yeah.
The topic is frequently dry wet cycles promote debris flow occurrences. Very pertinent to Nepal too. Application in susceptibility assessment. I would like to give some introduction of the presenter. Just a minute. GIERU. Where is it? Sorry. Listen. GIERU. Okay, yeah. So, Dr. Lee, I think it's easier for me to pronounce, is a dedicated PhD candidate hailing from Sichuan University in China. Is fervently committed to advancing the understanding of the intricate connection between extreme weather events and debris flow susceptibility. His research is characterized by a multifaceted approach, integrating cutting-edge techniques such as Geographical Information System, GIS, geostatistical methodologies, and state-of-art artificial intelligence algorithms. With a remarkable academic track record, Dr. Lee has left an indelible mark in his field, boasting a total of 9 published papers that significantly contribute to the knowledge in this domain. His experience is further showcased by his notable participation as an invited speaker at the prestigious XIB 24 IAEG Congress organized by the International Association of Engineering Geology. With this introduction, I invite Dr. Lee to present his presentation. You have 15 minutes for presentation. Thank you. Go ahead.
Okay. Thanks for your introductions. Can you see the slide well? Okay. I'll start. Good afternoon, everyone. My name is Jerry Lee, and my topic today is frequent dry cycles promote debris flow occurrence application in susceptibility assessment. And first, I will go through the background. The first background is the frequent and hazardous debris mostly occurring in the coastal regions and the mountainous regions. So as you can see from the map on the right. Sorry? Oh, okay. From the chart on the left, we can see that Sichuan province has the largest debris flow frequencies over overall China. So from these results, we can lead to the first research objective, which is determining the regions for prevention and the mitigation measures to reduce debris flow impact. And the second, so the professors before in the lectures before has mentioned some extreme weather events. So here are also some, but here, in China, in the coastal region of China, some cyclone super typhoon, just like can also affect the debris flow occurrence in China. But we all know that regions suffering from the frequent extreme weather events are prone to trigger secondary geohazards, such as extreme drought, flooding due to extreme rainstorms. So these phenomena lead to the second research object, which we need to develop new indicators that account for the impacts of extreme weather events to debris flow susceptibility assessment. So here is a flowchart of this research, and I choose the study area as Sichuan province in southwestern China, which is a province has the largest number of debris flow records. And then we just focus on the monsoon affected areas of Sichuan province, as you can see. And then we zoning this, we zones these monsoon affected areas based on the underlying surface characteristics, such as the distance from the faults and the elevation differences for watersheds. The watersheds is the research unit for this study area. We divided this study area into more than 1,600 watersheds. And for each watershed, we will calculate the driveway index time series based on the meteorological monitoring data. And then based on this driveway index time series, we'll conduct two work. The first work is to extract the driveway cycle characteristics for each watershed. And the second work is to make a predictions of driveway index based on SAREMA model. And then we will aid the driveway cycle characteristics into a machine learning model and combining the machine learning model results with the SAREMA model predictions into a susceptibility assessment map. So here I will show some preliminary results of this research. These figures compared watersheds and with and without debris flow. And for the y-axis, the PDSI is Palmer Drought Severity Index. The larger PDSI means the larger PDSI means wet conditions, while the smaller PDSI means the dry conditions. So by comparing the watershed with and without debris flow, we found that watershed with debris flow are in extreme wet conditions when debris flow occurred. And we also find around second year extreme driveway cycles before debris flow. This is by the statistical results over around more than 700 debris flow records from 1981 to 2020. So after that, if we want to extract more information from this time series and distinct the differences between the watershed and with and without debris flows, we should use some time series analysis method. First, I choose autocorrelation functions to extract extreme driveway cycle. For example, here we can extract the extreme driveway cycle as 2.3 years, and another parameters is multifractal is based on the multifractal spectrums, and these parameters can indicate the severity and the probability of extreme dry and extreme wet events. So by adding these driveway cycle characteristics into a machine learning model, we found that all these driveways, DWCC is driveway cycle characteristics. All these DWCCs contribute a lot for debris flow susceptibility, and which is in 3 zones. the relative influence of DWCC reached 73%, 42%, and 67%, which is larger than the underlying surface characteristics and traditional used maximum precipitation factor. Another findings is that the regions were based on the partial dependence plot. It can show the relationship between the DWCC and the debris flow susceptibility. And we find that regions with more geological activities and steeper terrain, which means zone 1, it will be affected less by the frequency of extreme drought, and it also requires a shorter extreme driving cycle to trigger debris flows. So the last is the dynamic mapping based on the machine learning models using DWCC, USC, and maximum precipitation. And the results show that 80% of the 25 debris flows watersheds in 2021 are predicted as high susceptibility. And this model was trained based on the data from 1981 to 2020. So it's quite a good performance of this model because we just only based on the driving cycle characteristics and some basic underlying surface characteristics. And then we want to do some other results, do some other work. For example, they're predicting if we can predict the PDSI time series based on these SARIMA models, we can predict the debris flow susceptibilities in advance. So let's see the performance of predicting the PDSI time series. It works quite good based on the statistic methods, but there are many outliers. We can see. I determined that they are all from the month in July, which means that the month in July, the precipitation is hard to be predicted. And for some future work, the reasonability of the PDSI predictions should be further tested via stability assessment models. So here is the short conclusions of this research. We can find that the driving cycle promotes debris flow occurrences from two aspects. The first aspect is debris flow watersheds suffer more extreme driving cycles based on the historical data. We have made a comparisons between watershed with and without debris flows. They are quite different. And the driving cycle characteristics contribute much to debris flow susceptibility according to the machine learning model interpretations and the model testing results. So for some future work, we should do some soil test to explain the mechanisms of how driving cycle characteristics are related to debris flow susceptibility. And also, as I mentioned before, the effect of using PDSI predictions based on SARIMA can also be tested based on further testings. So that's all for my presentation. And thanks for listening.
Thank you, Dr. Lee, for your timely conclusion of your presentation. We have one or two questions, if there are any, from the in-person presence here or from the audience from the online. Is there any questions from anybody? If not, we would like to move forward to the next presentation. Thank you, Dr. Lee, for your important work that, particularly very, pertinent to the mountainous regions like Nepal or any other parts of the Himalaya where, debris flow is the biggest killer, in fact, during this monsoon period. And we say landslides, debris flows and floods. And in fact, the real killer is the debris flow, which is so common in the Himalayas during the monsoon period, So your research is very pertinent and very important for all of us, those who live in the mountainous terrain. Thank you so much. And I will move forward to the next presentation.
Thank you.
Now we have in our next presentation is by Phumlani Sabelo Magnificent Joanne from South Africa, yeah. And are you there, Mrs. Joanne? Are you there? Are you connected? Please unmute yourself so that we can hear you. See, looks like
It's not there.
he's not there. No. Okay, then if it comes, oh yeah, is it? No. So if the candidate is not here now, the presenter is not here now, we can even shift it if he is available for the next, slot. But then we move forward to another presentation now. This is Santosh Kumar Rai. I hope you are there, Santosh ji. Can you join us?
Yes, sir.
Oh, very happy to see you. Your topic is denudation process and material transport in the Himalayan river systems. I would like to invite you. Before that, let me just have a brief introduction of yours. What happened? What is the page number? I'm sorry, I'm just lost here. What is 7? Okay. Oh, up there. Yeah, I know. Okay, yeah. Dr. Santosh Kumar Rai is a scientist at the Wadi Institute of Himalayan Geology in Dehradun, India. His research group focuses on igneous petrology and geochemistry, specializing in areas such as geochemistry, geochronology, mass spectrometry, hydrology, and the web and erosion of Himalayan fluvial system. He holds a doctorate in isotope geochemistry and has a strong academic background in the field. Dr. Rai's administrative responsibilities include overseeing major laboratories, serving on various committees, and representing the Institute in state and national committees related to water and environmental issues. He has been recognized for his contribution with awards, honors, and Best Paper awards, and his professional membership includes the Indian Society for Mass Spectrometry, the Geochemical Society, USA, the Himalayan Geology Society, and the Indian Geological Congress. Dr. Santosh Kumar Rai's research has made a significant impact in the field of geochemistry and hydrology, with several PhD students under his guidance and a diverse range of projects in the field of earth sciences. He has contributed to various national and international committees and has made a substantial impact on the scientific community. By the way, I was the Water Institute fellow for my PhD, long time before, from 1975 to 79. And so I'm the alumni of Water Institute, just for the information to you. Thank you so much. And I invite you for your presentation. Please go ahead, Dr. Santosh Rai. Yeah.
Thank you, sir.
Okay, yeah.
Okay. So, thank you very much, sir, for providing me opportunity to speak on the topic of my interest, which pertains to the denudation and material transfer in the Himalayan river system. We all know that Himalayan river systems are very much crucial for the point of view that it sustains a major section of population residing near the Himalaya, and also supports a large part of Indian agriculture, that is the Indo-Gangetic plain, and also it is very helpful in sustaining many of the countries like India, Pakistan, and Bangladesh on the counts of sediment supply, which is required for making an equilibrium on the accounts of coastal erosion. If the coastal erosion is not compensated by denudational product from the higher reaches of Himalaya, so there will be a mismatch in the sediment supply and coastal erosion, and some part of the territory of the Bangladesh and some part of the Indian territory may be lost. So that's why the Himalayan fluvial systems are important to study. We understand that there are several river systems in the Himalaya, and out of which Ganga, Brahmaputra, and Indus and Irrawaddy are very much important, as they have very strong component of snow cover in their headwaters, and that makes them with full of water all the time, and it supports a lot of people and livestock down the stream. So there are several issues in the system, in the Himalayan system, right from how that climate change in this region is affecting our day-to-day life, which includes that moisture source and apportionment of snow melt contribution to Himalayan rivers, and meteorological monitoring of natural stream events, particularly in the glacier flood systems, and also the time series analysis of water sample from different rivers like Brahmaputra and Indus also, which are and in the Nepal also, which are transboundary river and needed to be checked for any extreme down the people. So I am just taking this Ganga Brahmaputra system. So we have conducted some studies on the erosion rates. We have computed erosion rates in the Ganga and Brahmaputra region, and try to estimate whether the nature of erosion is uniform throughout the entire stretch of Himalaya, or it varies, and if it varies, then what are the possible reasons for this. So erosion and its distribution in the Himalayan system is very much important. We know that Ganga and Brahmaputra are one of the major rivers which ranks first in the sediment supply, and it supplies sediments from the higher reaches of the Himalaya and dump to the Bay of Bengal Sea and in the Arabian Sea, so that in that way they are the natural supplier of sediment, and which they supply the sediment to compensate for the coastal erosions in the countries like Bangladesh and India. So I want to conducted a study in the Ganga basin, and the basic problems and basic question I addressed was like this: what are the sources of sediment in Ganga plain and the Bay of Bengal, and the relative contribution of all these sub-basin to the sediment and the water budget of this Ganga, which was very important to address the sedimentary budget and material transfer from higher reaches to the distal sea like Bay of Bengal, and what are the spatial variabilities of the physical erosion and its implication to the regional tectonics, and identify to the major control on erosion and weathering, and how physical erosion controlling the weathering and the river chemistry and the evolution of water from its headwaters to the Bay of Bengal. So for this, we use certain isotope like particularly neodymium and strontium isotopes, which are very much diagnostic to trace their sources. And for this, if we plot these two isoplot on different end members like Deccan basalt, Vindhyan, higher Himalayan, and the lesser Himalayan crystallines, and some of the Archean terrains. So we see that most of the sediments coming appears to be coming from the higher Himalayan crystallines because they fall very close to HH3 end member. So this shows that one of the main supplier is higher Himalayan crystallines. And for this, we found out that if we take different rivers, we know that Ganga river is joined by different tributaries like from the north like Gomti, Ghagra, Gandak and Kosi. Out of these, Ghagra, Gandak, Kosi are the three mighty rivers which are coming from Nepal and joining the Ganga river in the Bihar plains. And also from the left, that is the Yamuna and Son. So we wanted to make the isotopic composition at every junction point before and after the confluence, and try to address the influence of these tributaries on the main sedimentary budget of the main channel. So for this, we adapted a simple mixing model that upstream of the main channel, downstream of the main channel, and the tributary. So we wanted to put it in the simple mixing equation and try to find out what is the contribution of a particular tributary. So with that, we wanted to estimate that sedimentary budget and its contribution to the main channel. So this exercise yielded a very important result, which was published in JGR, and it demonstrated that among the tributaries of Ganga, Gandak river is one of the important contributor of sediment, which almost have 45% sediments to its main channel. In contrast to the Ganga headwaters and the Kosis and Ghagra, Gandak is supposed to be supplying highest sediment in the Ganga main channel. And the probable reason, if you look at that average precipitation map at the right upper corner, that the Gandak basin is having very focused precipitation in its headwater. And also, if you see the relief profile map, the Gandak river has a very steep profile. So this relief, in conjunction with the focused precipitation, it is generating a lot of sediment, which is responsible for supplying very much very high contribution to the Ganga main channel. And one of the major information which yielded from this research, that we see that one of the highest peak, Dhaulagiri and Annapurna range, which are one of the highest peaks, are a manifestation of deep incision of Gandak basin in its high reaches. And due to this, this Gandak river is continuously cutting this Himalayan ridge, and the two peaks are continuously getting up under isostatic rebound condition. So they are getting again up and up. Similar things are also there in the eastern syntestic band, where Gayala Peri and this in the Nanga Parvat also, because these areas are even higher erosion rate they are attributing, because their rocks are crumpled in wake of this bending, and that's why a small amount of even precipitation can generate a lot of sediment. So this is we could generate that distribution of erosion over the entire stretch of Himalaya, And this gave us a fair idea about that how the upper reaches of these rivers in the Himalaya are getting eroded from their in situ position. And the second one is in terms of the flash flood, which we use in which we use isotopic proxy to trace it. That pertains to from a sample from the June 2000, where a flash flood was occurring from the upper reaches of the China in the Brahmaputra section, where it caused a lot of damage to people downstream in India, in particular in the Pasighat area, and it killed at least 30 people and missing 100 and rendering 50,000 homeless. So how to trace such event, that what was the source of this first flood? So we used that strontium isotope as a proxy to trace this event. So, and we also used some satellite data to pinpoint this. So if we see that there was a September 23rd, September 99, and that the river was Yogang River. Yogang River was flowing all normal, but after some time, up to the November, after some time in here, it got dammed with this landslide induced. A dam was created, and this lake was this river was swelled, and finally it breached very heavily. So we use strontium isotopic composition, and we demonstrated that how this isotopic proxy may be as a tool to trace the flash flood of the streams. So we collected some time series sample at Guwahati, and this we detected that breaching side was this much. So normally, if we see that a lot of water comes in the month of July, particularly in the Brahmaputra system, but when we measure the ionic abundance in these waters, we found that in July or June-July, their concentration was higher. So that was against the established principle that in the monsoon season normally the ionic concentration should be diluted. But we were puzzled by this observation. So we thought that how it is possible, and finally we could try of some other isotopes also. So we could find that what are the higher Himalayan
There is some hitch on that presentation. Is it internet connection on that side or this side, Pradeepji? No, it's okay here. So there is some problem on that side. Internet connection. Looks like it's coming. Dr. Rai, we may have to stop at this stage if it's not coming in 1 or 2 minutes. Hope it will come. Yeah. Let's give 1 or 2 minutes to restore, if they can, for the internet connection. This is kind of, expectations we have many times. We lost connection yesterday, right? From Africa, from Ethiopia. We couldn't get connected. So what we can do is, if we can get back Dr. Rai later on, in case if after finishing this presentation, we can go back to him, and then, he's almost finishing it, and then we can have 1 or 2 questions. But then in the meantime, let's go forward, proceed forward for the next presentations, because it will be not advisable to wait for a longer period. Dr. Rai, if you are there already, not it, right? Okay, So we go to the next presentation for the time being. All right. So I would invite now the next presenter, Nidhi Tomar from India. You're the one?
She's online.
She's online? She's online.
Yes, sir.
Okay.
Hello.
We can see you. So I would like to invite you, and the title of the presentation is Palynological Assessment of the Present and Past Vegetation Diversity in Relation to Climate Change in the Himalayan Region by Nidhi Tomar, India. Nidhi Tomar, currently a Senior Research Fellow at the Bengaluru Institute of Paleosciences, holds a Bachelor of Science in Biodiversity and Conservation from Guru Gobind Singh Indraprastha University. She entered her BSc Honours in Botany from the University of Delhi in 2015. Nidhi's ongoing PhD registration at the Academy of Scientific and Innovative Research focuses on climate reconstruction and assessment of ecological changes during Holocene in the Western Himalaya. She commenced her doctoral journey in January 2021. Her impressive list of publications includes contributions to well-known journals such as Frontiers in Ecology and Evolution and the Journal of Asian Earth Sciences. So now I invite Nidhi ji for your presentation. Thank you.
Thank you so much, sir. Shall I share my
Share slides.
screen?
Not it.
Hello. Hello. So, am I audible?
Yeah, you are audible. Very nice.
Okay, so then I will start sharing my screen. So is it visible?
Looks like, yeah, good. So you can proceed now.
Okay, a very good afternoon to all of you. Myself, Nidhi Tomar, and I am pursuing my PhD in the Quaternary Palynology Department at Birbal Sahni Institute of Paleosciences, Lucknow. And I am pursuing my PhD under the supervision of Dr. Parminder Singh Ranhotra, sitting right beside you. So today I take this opportunity to talk about the palynological assessment of present and past vegetation diversity with respect to the climate change in the Himalayan region. So just like everybody talked about a lot of climate change and drastic events all across the globe. Similar thing happened in the Himalayan zones also. And Himalayan region is, why is it important? Because it has a enriched and very diverse biodiversity and climatic variations. The reason behind it, because it is controlled by the two major monsoonal systems. One is Indian summer monsoon and other one is westerly disturbances. These two monsoon systems play a very crucial role in controlling the vegetation dynamics and the glacial dynamics of the Indian subcontinent. Also, the Himalayan region is it is characterized in varied zones of vegetation, varying from temperate to alpine vegetation zones. And the region holds various depositional landforms such as paleolakes, meadows, peatlands, and dense forest, which are the ideal sites for assessing the present and the past vegetation changes and past climate reconstructions. As we all are talking about the climate change, this ongoing climate change and this unprecedented and what do you say, this trending global warming has affected these regions also, and it has resulted in noticeable changes in the vegetation and hydrology of the Himalayan region also. Sorry. Especially talking about the subalpine and the alpine zones of Himalayan regions, these zones are highly susceptible to the vegetation change, climate change, and they are quite sensitive in terms of tree line shifts and glacial fluctuations. Hence, these zones prove to be the best zones and provide the suitable sites for studying the present and the past climate changes. Since recent decades, a lot of attention has been paid in the various regions of Himalaya, and there are various paleoclimate available. But the problem is these records they have very discontinuous records. They have or these data are on poor resolution. The reason behind it, because of due to age constraints or poor dating material. And so what happens is we do have the lot of data present from these areas, but their poor resolution and coarser discontinuous record, they hinder us from understanding the temporal monsoonal behavior and how it has impacted the hydrology and ecology of the Himalayan region. So to overcome this issue, Palynology and the science of palynology plays a very crucial role in providing a better understanding of the biodiversity and uniqueness of the Himalayan ecosystem and how it has varied with respect to climate through the geological time. So this map depicts considering the vastness of the Himalayan region, this vastness of the Himalayan region. It till now it has like major portion of it has not been studied yet, and a number of studies, palynological studies carried out throughout the Himalayan range is quite very low. These are some of the past studies that have been conducted in the different regions of Western Himalaya. As my target concerned study area for my PhD is Western Himalaya. So all these scientists have worked through the Western Himalayan regions, but their discontinuous records or poor resolution records have not yet enabled us to understand the climate changes and changes in the vegetation and local climate at a very finer scale. And if talking about the modern vegetation studies, they are quite fewer than the paleoclimatic studies, and their limitation is they have not characterized or their sampling, they have randomly selected any valley and they have explained them randomly. They have not defined the valleys or the areas into particular vegetation zones, and they have not like studied the extensively altitudinal range. So to overcome that issue, overcome these research gaps, I have chosen palynology as a major tool for my research. And for that purpose, we collect various samples for extracting the pollen. For developing the modern pollen vegetation relationships, we use surface soil samples and moss polsters. These samples are collected along an altitudinal gradient across the valleys. And for preparing for extracting the pollen or for creating a reference line, we do prepare the herbariums and we take out the flowers and prepare living slides from them to so that they can act as a reference from the present. And each plant type is depicted by the definite type of pollen morphology. So plants are the presence of any kind of plant or any vegetation is depicted by the typical assemblage of different type of pollen grains. And further, these samples are taken for microscopic studies. And for paleoclimate data acquisition, we collect samples through coring and trenching. And these subsurface samples are further subsampled at 1 centimeter resolution, and after drying, and these samples go through a series of chemicals in standard maceration protocol given by Fegri and Iverson in 1989. And we use this series of acids to extract the pollen from the sediments and to stain them, and then further these samples are taken in the microscope and pollen assemblage data is generated. Our team has been working since last few years in the various regions of Western Himalaya, and samples have been collected from the different valleys belonging to different precipitation regimes and having unique biodiversity, unique plant diversity, and they vary in terms of tree line limits and glacier snout position. So samples collected from different valleys are studied to understand the local scenario of each valley, and comparing these valleys, we can understand the scenario of vegetation change with respect to climate on a regional scale. So talking about the modern pollen vegetation relationship from the Bhagirathi, this is the one study from our group has conducted from the Bhagirathi Valley. This is the pollen data generated for this valley, and along an altitudinal gradient varying from 2000 meter above sea level to approximately 3800 meter. So from this data set, we could assess the difference in the vegetation distribution of various arboreal and non-arboreal taxa. Here, like here, you can see that arboreal taxa are dominating over the non-arboreal ones, and the blue zone marks the transition zone between the pinus and the quercus vegetation in this particular valley. So this transition zone, when coming for the past or for future studies, it can help us to assess the ecological change. It can be used a marker for understanding ecological changes in this region. This change can be possible because of the can be possible due to the human. Sorry.
You have 2 minutes left for a presentation to complete your presentation. Is it all right?
Sorry.
2 minutes more for your presentation, please.
So sorry, I'm not able to.
There is a problem of
properly.
from here. 2 minutes more for your presentation. Is it audible now? Okay.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. I'm about to finish. Yes. Okay. And the transition in the pollen assemblages of the tree line taxa such as Juniperus ericaceae and Betula abies, we can assess the changes in the tree line shifts in the particular valley. And this is the paleoclimate reconstruction from the same valley that we have covered the last 5,000 years, and we have been able to trace them signals of globally known climate events such as Little Ice Age, Middle Warm Period, and 4.2 event, with the changes in the abundance of dry and the wet taxa such as steppe taxa and tree line elements. We could assess how the climate has been changing through the past and what could be its trend in the future. Similarly, modern pollen vegetation relationship has been developed in the Baspa Valley in Himachal Pradesh. We have covered the altitudinal range from 2400 to 3400 meter AMSL. These marks, colorful mark circles, indicate the presence of typical type of forest, and which could be and which correspond to the present vegetation exactly. And in this valley, we could also mark the changes in the plants which are actually cultivated by the humans there, and micro charcoal activities. These, for example, Rosaceae, Juglans, and Polygonaceae, the Poaceae cultivated. These taxa variation in these taxa can help us to assess the trend of anthropogenic impact in the similar valley. And the same valley has been studied in the past and it has been used to trace the tree line shifts and the glacier retreat in this valley. And with the help of pollen studies, we were able to assess that the tree line in this area existed at 3,100 meter ASL in the past, and currently it has shifted to the nearly 4,000 meter AMSL. This indicates the glacier has retreated in the past 5,000 years. And to conclude my talk, we can take a message that the combination of these modern and past palynological studies can help us to assess how the vegetation is changing now and how it has changed in the past. So comparing and calibrating these two types of data sets together, we can develop a trend which can be used by the future modelers or people working in the modeling zones, can help us to understand how the vegetation has been changing in the past and how it will be behaving in the future, so that we will be so these type of data set can help us to assess the land use management with relation to the climate change.
Thank you, Mr. Tomar, for presentation on a very important topic on climate change. Thank you so much. And I would like to have just one question, if there are any, so
Yes,
that we maintain our time schedule. We are already late by half an hour. So is there any questions from the audience here as well as those who are online? Question to Ms. Tomar. If no questions, once again, thank you so much for your very elaborate work that you have been doing on paleontological studies, and wish you all the best for your work. We had left Dr. Rai from Wadi Institute, and there was very little left. So if you are again back online, Dr. Rai, we would like to complete your presentation. Are you there? Dr. Rai, are you there? If not, then we like to conclude this session. Because of time constraints, I would not like to, really, summarize the things. Well, except that, I thank all the keynote speakers, invited speakers, and our presenters for coming forward and presenting these important results of your research, which are very useful and very important for our future climate research. So with this, I conclude this session, and again, thanking you all. And we move forward to the next session, and I hand over this mic to Dr. Jayshree. Thank you.
Thank you so much, Professor. So this was a wonderful session. We had so many wonderful talks, and I'm sure that young scientists would have been really benefited with the talks we had in this session. So we do not have much time today, so I would like to request you if we can have a shorter break, like for 5 minutes, and we all join back around 4:10. Is it okay? So maybe we'll see you back at 4:10 with 5 minutes break, and then we start our 4th session, which will be on climate change and Earth system. Thank you so much. So we'll join us back. Please join us back. So I trust you have a rejuvenating break for just 5 minutes. And now we are prepared to embark on an engaging journey as we enter session 5, which is dedicated to the exploration of climate change and Earth system. So our first invited speaker is, he's a invited speaker for 20 minutes. He will talk. And Dr. Abdullah Harun Chowdhury, he is a professor and head environmental sciences discipline, Kullu University, Bangladesh. He conducts research on the ecological status and sustainable management of natural resources, climatic change, and environmental policies since 1993. He has published more than 65 research papers and books. He has attended more than 70 international and national conferences, workshops in home and abroad, and presented 48 research papers, 17 invited keynote lectures, and 5 panel discussions in the conferences, and honored with 6 best speaker presentations. He had received National Science and Technology Fellowship from MPhil and PhD. He worked as a program officer in IUCN Bangladesh and worked as a technical advisor of Japan Broadcasting Corporation NHK Television and technical member of the National Biodiversity Strategy and Action Plans of Bangladesh. So it's my immense pleasure to welcome Professor Abdullah Harun Chowdhury. Please, sir, the mic is handed over to you now.
Okay. Can you hear me? Could you please confirm?
Yes,
Can you hear me?
Yeah, we can hear you. So please share
Sharing, yeah. Can you see?
screen, yeah.
Okay. Thank you.
Thank you
Okay.
so much.
Okay. Thank you. Good afternoon, everyone, and namaste. Actually, climate change strategy and action plan in Bangladesh. Just I would like to share what is the climate change strategy in Bangladesh and how the situation of the Bangladesh in here. Just that there's in 2009, actually, Ministry of Environment and Forest developed the 6 pillars of the climate change strategy. Number 1 is food security, social protection, and health. Number 2, comprehensive disaster management. Number 3, infrastructure, including embankments and shelter, as well as number 4, research and knowledge management. Number 5, mitigation and low carbon development. And number 6, capacity building and institutional capacity strengthening.
I'm sorry to interrupt. Could you please share your full screen?
Yeah.
Mode.
Why this is not actually full screen? Sharing live. Yeah, I am trying actually. Stop sharing. Then again, I am. Yes.
Now you share your screen. So
Yes.
yes.
Okay.
Thank you so
Yeah.
much.
Okay. Thank you. So is based on the 6 pillars, actually, what is the situation of Bangladesh and how these are managing in Bangladesh? And you know that actually Bangladesh is southern part is closely attached to the Bay of Bengal, and full southern part of the Bangladesh are every year attacking by the use of cyclones, and sometimes super cyclones from 1991 to still we are facing the different type of climate change impacts in Bangladesh. Just I would like to show you here some ideas, and based on our research and continuous monitoring and evaluation. Here just I would like to show there is some overall impacts of the climate change, damage and losses of population, health, drinking water, housing and infrastructure, food and agriculture, sources of fresh water, education, industry and commerce, as well as is a transportation, as well as also there is a environment, which is the main issue of the now is a burning. Now next, I just would like to there are some direct and indirect impact on the social impact. Direct negative impact is the death of people, loss of houses, increased scarcity of food and drinking water, loss of occupations, increased health hazards, etc. Direct negative impact on the economical impact. There is a death of domestic animals, loss of agricultural crops, loss of cultivated fishery, valuable plants, and damage of infrastructure. And there are some indirect impacts are on social. There is an increased migration. People are migrating from their area to other side for food, increasing number of husbandless women. Because of that, these are most of the cases due to scarcity of the occupation. Husbands are they are leaving their area with their, but they are not actually communicating with their family members. And as well as different type of social conflicts are arising. Educational problem is arising due to destruction of the education institution. Social crimes are developing, social security is decreasing, as well as malnutrition of children is increasing, increase the number of poor people. And there are economic losses, that loss of the land fertility, loss of the habitat for plant and animals, increase price of the all necessary products, increase the transportation cost, as well as increase economical imbalance. And there are some positive impact. Which one we would like to note at that there are some social impact, like increased voluntary activities after the any disaster or any impact of the climate, any cyclones. There is increased the adaptation capacity, as well as increased compassion among the people. And there are some positive impact and economically develop new occupations and increase cash money flow due to the supporting by the different development agencies, governments, and etc., and develop new infrastructure. And the migration rate is there. I just would like to show that 42% they are always migrating in the nearby cities, and 14% they are migrating to the distant districts in surrounding areas, as well as there is a 23% there is a nearby places, and 21% they are going to the India for just illegally to enter the India to collect them. This is, there is some database. I am not going to the detail about the impacts. I just would like to escape those things. And before, I just would like to give you the one scenario of the super cyclone Aila. It was the natural condition before the cyclone, but after the cyclone, and this is the rice cultivation of the land, fish cultivation is there. This is the available normal houses of these areas in the southern part of Bangladesh, but after the cyclone, what are happening? Just I would like to show it after the cyclone. You have seen that the house damaged due to the cyclone and flash flood of the water, and all are underwater. You think that these are happened due to the cyclones and all are waterlogging, and people are actually damaged their houses. And you think that there's a saline water is coming due to the cyclone from the Bay of Bengal, and people are living on the roads by developing very temporary cars or others. And also this is the temporary living system they are developing, just make the bricks and temporary on the roads. Some people are taking the shelter in the school building for during this. And this one is a library, actually the Bengali term is right, and under the water is a library. And this is the photographs of the there is a relief distribution by the Lions Club. And you think that what is the queue due to the relief collection of the people by that after the Isla? I think that you could understand that. And this is the old woman just coming here with his a grandson, just with a token to take the relief. Actually, here is a different category people are coming to queue here, different ages. And you think that how many the scenario of the people of the, and the scarcity of the drinking water. I said that this actually a small boy came with his father to take a one bottle of water, and this is a school boys, and this boy is drinking the drinking water after the cyclones of the 7 days. And this small boy just arguing to give him a bottle of water, he will drink and his brother will drink. And what are happening? Increasing of salinity in the soil and water. And this is the scenario. You think that trend of the salinity increasing in this area due to the climate change. I think here I'm showing up to the 2018, because after that we could not do the study, because you know that from 2020 the COVID problem is there. So this is the red mark is the salinity increasing pattern in this area due to the climate change, as well as also earlier one is the soil, and this one is the soil, earlier one is the water salinity. How these are changing the total area. This land is covered by the salt. This white color is the salt during the dry season. And all plants actually destroyed. This is the banana plants. So this white color is all of the salt during the dry season. Due to the cyclone, this house, that is the forest office, just like the Sundarbans, beside the Sundarbans, that was destroyed. And you think that what is the scenario after this Isla? And all plants were destroyed by the salinity, land erosion increasing, as well as also there is a waterlogging of the houses, and people are actually, the old woman is just standing in front of his house, and you think that scenario, they are standing. This is a black operated a school, but it is underwater actually. There's the toilet. You think that this one is turmeric cultivation, but underwater, and damage of the embankments, and PSA, ponds and filter, is a locally developed, is a water purifying system already damaged by these things. And you have seen the water body is contaminated by the saline water. In that cases, these are all, and this just like a they are unsafe drinking water collection by the rainwater they are depositing for drinking. You think that this is a microorganisms already growing. There is a cyanobacteria, or you can say blue-green algae, but they are bound to drinking this type of water. And they are collecting the pond water, that is unsafe water for the drinking. How people are doing the collect their drinking water every day from this type of ponds. And this is the embankments. People are living on this embankment, no vegetation due to increasing of the salinity. And this is a hanging toilet, because they have no place for the toilet, and unhygienic toilet they are using. This is a and this is the scenario that lady and his son is doing the bath, as well as somebody is using the toilet. That means that which water, that is a very unhealthy and situation. They are using this type of water because they are bound. This land is barren land due to the increasing of salinity. Only few grasses is saline tolerant, no vegetation is there. So this is a crop land, but due to salinity increasing by flash flood impact of the climate change, no crop is cultivating. And resilience of the livelihoods, how people are adapting these things. Still they are living, water is, but they would like to live inside their houses. Somebody would like to take the shelter on the road, and this is the college building, but they are took the shelter on the roadside. Somebody would like to make the tents in, and this is a college building, and tubewell underwater, toilets, everything underwater. And somebody is cooking in the rooftop of their house to adapt it themselves during the tidal condition as like their water. Somebody is taking the shelter on the roadside. Very old woman, he is also took the shelter in this type of houses with that. Somebody is living on the boats, and these women, they are going to the river for collecting the fishes and others with their children, because they are the husbandless women. Earlier I mentioned that why their husbands are living, and these two children are going with their parents to collect the drinking water with these jerrycans, and these women are going to collect the fish fry, because, and these children actually going to collection of the shrimp fry, because they are not interested to go to the school, because the old woman, he is bound to go to the also the water bodies to collect some fishes for living. And that woman, they are collecting the drinking water from the far away by the jerrycans, living beside the embankments. Then they are collecting the drinking water and supplying the local peoples. And this is the rationing system. They are collecting the, is a drinking water. This is a card of the rationing card. They are very happy, and this boy is very happy after collecting the just like a 1 bucket water, drinking water. These ladies are collecting the drinking water, and you have seen this is a queue to collect the drinking water after the sun. And women are bound to work for their surviving, because they all are the husbandless women, and they are doing the working. One is a Muslim, another is a Hindu people. There is no religious, actually. Earlier I mentioned that the compassion due to the problem of arising. So for their living, they are bound to work together, and as well as these children are not going to the school, but they're collecting the crabs, because by selling this crab, they can earn some money, they can survive. These women are collecting the fuel leaf. Actually, this is the floating leaf of the Sundarbans. Those are coming with the high tides, and they're collecting this after the drying. That old woman, they just dry it and make it a fuel. And this old woman is just begging, because he has no alternative, because his family is not capable to bearing his all cost. And people are bound to use this type of locally made actually medicine, because these are very, I think that this is a Bengali term, sorry for that, because the local signboard, because very locally street medicine they are bound to use for their treatment, because they have no alternatives, because they have no money. And he is selling some type of the mixture medicine. He is a doctor, but I know that he is also affected by the different type of diseases. Very old mans, they are collecting the medicine, because they have no alternatives. But after this condition, some people are trying to survive by doing some very small business. You think that the very small shop just beside the river sides, and this woman is also doing this very small business. I think that selling something, and he is also a husbandless woman by taking the financial support from the any NGOs, and he is doing. And after doing these things, everything, but somebody would like to trying to survive. That's why they're making the is a ice cube, and they're supplying to the fishermen, and by the boats they are taking this is a go to the Sundarbans and rivers. After fishing, they would like to preserve it, and this is one kind of the locally made the trapping, fish trapping or fish collecting trap they are making for the surviving. And here you have seen that very locally, one of the saloon, somebody is cleaning his faces and others. One thing we demand that is a cyclone is coming, disaster is coming, climate is changing, everything is happening, but our beard is not stopping to grow. So we need to clean it. That's why he is coming. That means everything is happening, climate is changing, we are suffering, but our life cannot be stopped. We have to adapt with these things. And also some people are doing their religious activities, and they are just enjoying things. After that, they would like to arrange the exhibition, and she is selling some sweets locally made in the exhibition. So life cannot be stopped. So which are necessary during this situation in the climatic condition of the Bangladesh. Every year where we are suffering by the climatic conditions, changes of the climatic conditions, as well as increasing of the temperature, high saline increasing, as well as heavy rainfall is coming, tidal surge is coming, everything is happening. What we have to do? We have in the southeast coastal area, we need the proper embankments, as well as also repairing this type of embankments. We need this type of is a ponds and filter, because due to the salinity, deep tube well is not working in this coastal area. So this type of and excavation of the new ponds where the rainwater will be preserved, people can collect these things. They have to increase their plinth of their toilet, this one, because this one will not be inundated during the tidal surge, and their house is a plinth should be of this house should be developed. That means they need the safe house to protect themselves from the tidal surge. And this is one of the aborigines people locally named is a Munda. You think that there is some estuaries. So this is a low actually rooftop, because that rooftop cannot be removed by the wind flow, as well as also they need the high plinth which will not be inundated in the tides. This is a indigenous knowledge. This practice is happening is a last more than 300 years in these areas. They need the cyclone shelter, this type of multi-purpose cyclone shelter, where they can use this thing, cyclone shelter, for the different types purposes. This is a Bengali term, but here they're keeping their seed, they're keeping their agriculture products and everything, and also they can keep their all is a necessary and important materials like is a deed of their lands, money, gold, everything they can preserve here. This is the area where they can meet the meeting. And finally, what is the conclusion? Conclusion is that there is a salinity and natural calamity tolerant crop and plant species are necessary. Already these are practicing in the coastal areas, some areas, but we need the more things. Indigenous seedlings with main roots need to be used for plantation. Otherwise, if most of the plantation when we are doing, there's a main root is cutting, removing. As a result, what are happening? They cannot survive during the tidal surge. They can, or even heavy wind flows. So some natural area need to be classified as habitat of the different plants, and commercial activities need to be prohibited inside that classified areas in the coastal areas. Emergency shelter, safe drinking, water resources, treatment and sanitation facilities need to be increased. Only local varieties, goat, sheep, and swan must be used for farming, because sometimes after this calamity, people are supplying the NGOs and other, they're supplying, there is a different type of domestic animals for the development of the economics condition of the local area people. But I think that after the long research of us, we have seen that only local variety can adapted with this climatic condition. Other varieties cannot be adapted. And saline water shrimp culture practices should not be extended further in the southeast coastal area of Bangladesh. You know that in the most of the southern part of Bangladesh, it is famous for the shrimp cultivation, which are exporting in the different countries, but further extension is not necessary, because shrimp cultivation, unplanned shrimp cultivation is creating the problem, is change in the climatic condition is that area. For your kind information, saline water temperature absorption capacity is high. As a result, in saline contaminated areas, the temperature is always high, because they can easily absorb the high temperature from the sunlight. And professional training on the safeguard and rescue mechanism during the disaster are necessary at local levels. Participatory community management is necessary in climatic disaster risk reduction and adaptation issues. Awareness raising need to be continued among the people on the impact of climate change and salinity intrusion, and importance of safe wash. And microcredit support is essential to improve the livelihoods pattern. Just I would like to recommend a few things. One is that to reduce this negative impact on the socioeconomic condition, it is essential to launch a local area-based weather forecast system through community participation. GOs, NGOs, local government, microcredit organization, and intellectual groups should work jointly in climate-affected areas. And indigenous adaptation capacity building must be increased through community participation. political commitment and interministerial coordination are necessary to work jointly to mitigate and adaptation in climate change. Why political commitment is necessary? Because you know that your country, our country, in this third world country, there is a different type of political conflict is there, but climate change is not actually identify any political person. When they are affecting, they will affecting the all group of the people. That's why it is very important, the political commitment, and interministerial coordination is important, because due to the unplanned way any development is developing, which is actually enhancing the different type of climatic impacts, and integrated research is necessary, which is the one of the important pillar of the Bangladesh Climate Change Strategic Action Plan, to find out the mechanism of sustainable climate management, community management, climate change is reduction, risk reduction, and safe water and sanitary and health is necessary, and livelihoods management in climatic change affected areas. Here I am showing you one just floating material that is indigenous knowledge, that those women actually develop these things for movement of their house to other places, just to collect some dry straw as a food of their domestic animals. So we would like to encourage the all indigenous knowledge adapting in this type of climatic condition. And one thing just I would like to comment is that climate change is now burning issue in everywhere. I know that in your country there is a climate, temperature is increasing, ice melting is developing, sometimes a sudden flood is happening, flash flood is also happening in our country. When flash flood is happening in your country, this water is coming India, and India, that water is coming in Nepal, Bangladesh, because we are in the downstream. So we are connecting the all rivers, maximum rivers are connecting with India and Nepal. So here we are interconnecting. So I think that we had to develop a country a climate change policy based on either SARC or any other way. I think that conference can find out this type of the mechanism, how we can develop the climate change and their mitigation and problem in this South Asian all countries like India, Nepal, Bangladesh, Bhutan, and as well as also Pakistan, etc. So thank you to all of you for giving me the opportunity to invite me these conferences, especially thanks to Professor P.K. Jha and all other organizers to you. Thank you.
Thank you so much, sir. Such a wonderful talk. I mean, like, it's what to say. I have actually lost with many words now, because it's very heart-wrenching also to see the kind of life people live. And in another side, like, we have so many things, fresh water, everything we have, but we are still misusing them. We are like, playing with the nature and the kind of conditions people are living in Bangladesh. And I really thank you so much for bringing these things into this kind of forum, where I think, the policymakers and others also should be aware of these kind of problems, so that to mitigate them or make the strategy and the plannings and take it further as one of the most important biggest issue that climatic change cause in Bangladesh. So I would like to thank you again. And the session is now open for one or two small questions, if anyone have. If not, then maybe we can move to. Okay, sir. Yeah.
Hi, Professor Chowdhury.
Thank you, sir.
How are you?
Hi, how are you? Yeah, I'm fine. How are you?
Yeah. So thank you for emphasizing the vulnerability due to climate change in Bangladesh. We know that Bangladesh is politically one of the most vulnerable countries in the world, like Nepal. Perhaps it stands in the third position in politically vulnerable countries. Yeah. And I believe that Bangladesh has NAPA, National Adaptive Action Plan for Adaptation due to climate change. I believe we should have, isn't it? NAPA.
Sir, could you please mention again, because sound is not clear actually.
Bangladesh should have a national action plan for adaptation due to climate change. Many countries, Nepal is the country, so we should also have the document, national document. So the requirement is simple, the access to the hospital, because the implementation part is in countries. So that's my information conference in March. Second information conference on March. Are you listening?
Actually, sound is not clear. Actually, voice is coming and up and downing. So that's why it's very difficult to understand.
It is not audible, then sorry. Yeah, so the second question is that you are going to organize and the second international conference on environment.
Yeah, sir. Yes, we are going to organize the second international conference in 2nd and 3rd March. So all are invited in our conference. So I think you have you will get a new experience in southwest coastal area of Bangladesh, as well as all these areas. And we have one arrangement to visit a short visit in Sundarbans. You know that Sundarban is the one of the largest mangrove forest in the world, and only one largest mangrove forest in the world. So you all are invited in our conference. Okay.
Okay. Yeah, thank you so much, Professor Chaudhary, once again for your wonderful presentation. So I'll move forward with our next presenter, next invited speaker, Professor V.C. Tiwari, and I'm truly delighted to introduce him. He's Emeritus Professor from Sikkim University, India. With over 50 years of research experience, his expertise spans Himalayan geology, paleoclimatic changes, paleoglaciers, stratigraphy, sedimentology, isotope geology, Holocenes, Paleothenes, and the Indian summer monsoon. His significant contributions includes 150 research papers in high-impact international and national journals, as well as edited books and special journals issue on Himalayan geology, stromatolites, paleobiodiversity, and climatic change. So with these words, a small introduction, I would like to call upon Professor V.C. Tiwari from Gangtok, Sikkim. Thank you so much. And the topic of his lecture will be today, Global Paleoclimate Change in the History of Planet Earth, Evidences from South Asia. Thank you. Over to you, Professor Tiwari. So please unmute yourself. We are unable to hear you. No, we are still not able to, you are not audible still. No, we are still unable to hear you, sir. Could you please unmute yourself if I'm audible to you?
Professor Tiwari, I think you are muted, so you have to unmute your computer. We are not listening to you. Your voice is not coming. Can you now check? No, we can't hear you still. We can't hear you still. What happened? Is there any problem from this side? No. So it's from that end.
So if you try to unmute yourself one more time, like mute it and unmute it, it might work. You are still not audible to us.
Volume. Check your computer volume. The volume of the computer. Not it.
Or maybe if you can rejoin the meeting, just exit and rejoin. That might help.
Not yet. We can't hear you.
It's on mute. He will rejoin maybe.
Okay, that will be better. Yeah, sometimes. Sometimes it's.
Yeah, so once he reboot, then we'll be able to hear him, I think, probably. On quaternary palynology and dendrochronology. He specializes in reconstructing paleovegetation, paleoclimate, and paleoecology in the Himalayan region. His research goals encompasses developing modern pollen vegetation relationship for Himalayan glacial valleys, assessing temporal changes in vegetation types, understanding the impact of climate and glacial episodes on fine, temporal, and spatial scale, and investigating the ecology and tree line dynamics in the higher Himalayan region. I would like to thank Professor Parminder Singh Ranhotra to join us in person. So I'll hand it over to him. Please start your presentation. Thank you so much.
Yeah. Hello, everyone. Full screen here. Is it a great response? Oh, you can't see it here. Huh? Oh, you have to mute. First you mute. What is it? Yeah. Oh. Okay. And. Oh, yeah. It's not that complete. Here you can see. There. Why there it is not showing? Yeah. Huh?
Yes.
Yeah. Connected to Zoom with that link only.
Oh, it is okay. Readable. It's like in the. Not say the slide.
Yeah, you using the mic.
Mike.
Yeah, you using the mic. Yeah.
So, and then. Thanks. Again.
Slide change. Slide change is also not visible. Here it is changing, there it is not working. Why this so?
You stop. No. You stop in the once again and share again. Yeah.
Okay.
Yeah.
Yeah.
Share.
Yeah.
I think now it should work.
Yeah. In this side?
Yeah, this one. No, but there.
I think if we share the full screen, entire screen, then it will close. If we share the entire screen.
Where?
No, if skip this, please.
Stop.
Stop sharing.
Share.
Stop share.
It stopped.
Stop.
Sharing
Okay,
stopped.
again, start. Your entire screen.
Okay, entire
Yeah,
screen.
Yeah, and again. You know.
Now it's okay.
You get.
Mhm. Okay. So once again, good evening. And first, I would like to thank the organizers here. This is my first visit to Nepal, and here I am going to present some of my work related to the Holocene climate anomalies and impact on the vegetation dynamics in the Himalayan region. Changing. Yes. So as we all know that we are talking about the climate change, and so we are in a worry that what is going to happen in the future. Extreme events, floods, droughts, all these are happening in so many parts of the globe. And for now, since I have seen a few presentations from the Asian region, so they are also like this region is also very badly affected due to the extreme events. So for the future sustainability of our food, water supply, and how the economy is going to affect increasing population. So we have to think about this climate change and how this biodiversity and the hydrology, it is going to respond in the future. So we are doing all these research, all these studies, so that we can do for the future sustainability of these our resources. So I'm talking about the Himalayan region, which is very crucial and critical. And because of the climate change, because of the increase in the population, exploitation of the resources in the Himalayan region. So we have to understand means how this changes what we are doing, whether it is we are saying the anthropogenic impact or it is due to some other forcings by the nature. So we have to study all these things. So what we have tried to do, that is to reconstruct the past, like how the here I am taking the tree line shift, means how the vegetation has responded and how the tree line has behaved since past during the Holocene and in the recent years. So I have used these two parameters, pollen spores and the tree rings. My one student has already talked about the palynology. So I will just come to the output because most of you have already seen that presentation by my one student on this recent pollen analysis and the past reconstruction. So this is one of the slide which he has already discussed. So I'm not going to discuss much on that, but some of the few things that if you need to study in the recent and for the future, you have to see the behavior, how these, how the vegetation and the tree line has responded in the much past and in the recent past. So using this palynology for this recent approach and a relationship between the pollen and the vegetation, this has already been discussed and this is very important to understand. So here one important fact means in our study that the subalpine and the alpine taxa, some of these alpine taxa as you can see here, juniper, rhododendron, birch, they are taken as an indicator of the tree line shift and the glacial movements. So based on this, we have tried to see like how the trees in the past in the Himalayan region, though there are not any such studies like showing the tree line shift in the Holocene or back to the Holocene time. So here what we have conducted, we have tried to link this shift with the climate changes episodes, which are already well known by most of the studies, that we have the Younger Dryas event and then 8.22 event, mid-Holocene optimum, then 4.2 event, then MWP, then LIA. So all these climatic anomalies, how they have affected the vegetation, and whether the Himalayan region, in the Himalayan region also, there is like ISM region and the westerly dominant area are there. So how the vegetation in these two precipitation regimes, they are behaving. So this study was conducted from the ISM region, which is at Dokriani Valley in Gangotri region. The annual precipitation is around 1200 to 1500 mm. And we have analyzed a peat deposit and we have taken the palynological analysis. This was actually the work of my one student. She has already submitted the, her thesis in that and got awarded too. Sorry. So here you can see that there is a change in the vegetation type. Before this Younger Dryas phase, that is around 12,500, this pine population was very much, and most of the dry taxa were there in that area. This study was conducted from the subalpine region, which is at the altitude of 3,500 meters. So, but after this, after the Younger Dryas, after the commencement of the Holocene, you can see there is a change in the vegetation type, and this oak, which is actually the moist loving species, it has increased. But to that altitude, when the tree line came, according to our data, that means it was around 8,000 Ka. And also we have taken here some of the marker taxa, which I talked about, Juniperus, Ericaceae family, that is a rhododendron. When we started getting these pollen in the deposits, at what time? So we have used this thing, these important taxa, indicator taxa, to understand the tree line shift, because these pollen, they normally used to disperse by the wind, but these pollen by the wind, they can't disperse to the longer distance. So it is a very important the character of these pollen that we have used to reconstruct the tree line in the Holocene. So we started getting this rhododendron, and if we go to the tree line, then you can see that after this conifers and the Breshpatra, this rhododendron, it used to capture the higher altitudes above the tree line. So when they reached at this point, it is showing around the 8,000 USBP. So that means around 8,000 USBP, this rhododendron line was there. And then in the modern time, this tree line is much above. The conifers have already reached to the 3,600 and the 3,700 altitude. So this study we have conducted about the Holocene tree line. Now, if I come to, I'm just going to skip these of the slides because of the time. I would like to stick to some important points. So here then we use this tree. So how the tree ring has helped to understand that in the recent past, how the trees have behaved. Like in the remote sensing studies and all, we used to say that, okay, tree line has shifted to this much of the altitude. But this ground truthing we have done, which was actually not taken from most of the Himalayan region. And from Nepal region, Dr. Gaire and Achyut Tiwari, I think they have taken on this tree line studies. So we also conducted from the 4-5 sites from the Western Himalayan region. Like Little Ice Age is used to be said that, okay, it was a cool phase, and after that the tree line is shifting. But here you can see this diagram. We have taken a large number of trees from the altitudinal transit up till the tree line, and we have taken the age of these trees, that when they arrived at that altitude, when they started establishing at that altitude. And the results were like very interesting. So these are the 4 areas, like from the Uttarakhand and Himachal, and then the Kashmir region. So Tumnath, Triyugi Narayan, they are from the Uttarakhand area, which is actually the ISM dominant. Then this Chanchal is in Himachal. This is also ISM dominant, but westerly effect is more as compared to Tumnath and the Triyugi Narayan. And then this Kashmir area, which is mainly dominated by the WDs. So what you can see here, a number of trees. So at this altitude, where the tree line, the top tree also exists, that is the 3,500 meters in the Kashmir region, we have found the oldest tree of around 400 years age. That means it is already during the Little Ice Age, already the trees, they reached to that altitude. And just coming down, so we have found the more older tree, older than the 450 years. And then similarly in this Chanchal area also, above the 3,400 altitude, we have found the tree which is near about 400 years old. And in the Tumnath area also, the tree line, which is at present around 3,400, but at the 3,300 meter altitude, we have found the older tree, which is also more than 450 years. That means, what was the effect of the Little Ice Age on the tree line? That was a cool phase. And now, since we are talking about the warming, and on that we have also conducted that how trees, they have a good growth response with the climatic parameters. So this study was from the Kashmir. So we have tried to build the drought reconstruction, drought index for the past 1550 years to 218 CE. 2018 CE. So here you can see that there is a demarcation of this LIA phase, which was in the Kashmir region, it was wet. And other studies from the speleothems, Jashi is here, her studies also, they showed that the WD was more prominent during this LIA phase. So that means because of the wet conditions, so that phase was having the wet conditions, and this was from on the Abies species. So this Abies is also moist-loving species, because I have seen this Abies mainly where the moisture content is high. And then we have analyzed some our tree indices with this sea surface temperature, and then we find that there is a change in the response behavior, the behavior of the trees. So they have shown more affinity from 1960 onwards. They have started showing the more affinity with the sea surface temperature of this Bay of Bengal and also the Pacific Ocean. So this is also where that is climate change, this unprecedented rise in the temperature, how they are also affecting the growth response of these Himalayan species. at this far distance. Then there are some other forcings. So we are still trying to compare it like volcanic events. So we are in that study. So the highlights here, we can say that this, if we are taking the post-LGM, so in the pre-Holocene time, these valleys were much dominated by the pine forest, which is actually a dry-loving species. And then after this means during the Holocene, this pine started declining in the ice-dominated valleys, and then oak became more prominent. And if we come to the recent period, that is from the 1500 to 1850 AD, which was taken as a LIA. So the WDs were strong, but the tree line must have attended the altitude of around 3,400 meters. So now if we are talking about this impact of the climate on the tree line, but there are studies from the Alps and the other region. They have shown that the human impact also started from the late Holocene. It became intense in the late Holocene. So how the tree lines, they are being controlled by climate, okay, but also the human impact and as well as the topography of the region. So there is also one study by our team also. I have not put that slide in this. They have also shown that during the past few decades, some of the tree lines they became stagnant, and I think my student will present on the Devdar. So the growth trend during that time, it has started declining for some of the important species. So I think we have to still go far to understand this, how in the past these trees and the tree lines have behaved, and how much this climate change has impacted these tree lines depending upon the region to region. So I end here my talk. So thanks to everyone and the committee also. Thank you.
Thank you so much, Dr. Parminder, for a nice, wonderful presentation. So, yeah, just one simple question from my side. You mostly talk about the tree line. So, is it based on the temperature or the precipitation? Like, what do you think that they are more sensitive to?
Both are important factors, because if you see some of the species, if you go to the higher altitude, the temperature plays a more important role. If you come to the lower elevations, then the precipitation plays an important role. So it depends. Since now the warming trend is increasing, so the higher altitude, the temperature is also increasing. So whether these trees at the higher altitudes will be able to adjust with this rate of the temperature rise. So this is also a question mark. Means how they are going to adjust. Suppose if it is a very gradual, then okay, they are going to adjust. But if it is so rapid, like a hockey stick or as we used to see, so then how they are going to adjust themselves? That is the thing. But both means temperature and the precipitation, both are important. Okay. So we need to analyze that, okay, which one is a limiting factor, like whether it is a temperature or the precipitation. It depends on the region to region. Okay. Where it is precipitation is enough, then maybe the temperature is a main controlling factor. And where the temperature is okay, then precipitation becomes the limiting factor.
Okay, thank you. Species.
Yeah, it's all depends on the species also.
Yeah, and yesterday Dr. Tiwari had spoken about Pinus rockbergiae. So he stated one thing that maybe these trees are causing the dry mountains. So how far do you agree with this?
Pinus roxburghii.
Yeah.
So this is still because Professor S.P. Singh, I think you must be knowing. So
Yeah.
we used to have that discussion with him also. So he also used to say that whether this Pinus Rox Bergei is creating the soil moisture or it is the other way. Means where it is a dry land, Pinus Rox Bergei is increasing. So as we see that this extreme winds, rainfall is there,
Mhm.
but still Pinus is increasing. So whether these are the means moisture is not able to stay in the soil, like in the slopes because of this high temperature. That's why this Pinus is getting adapted. Or and also it is for fire resistant. Means if we can talk about the anthropogenic activities, it is a fire resistant species.
Sure.
So human being anthropogenic activity means this human fire or the forest fire. So in that this then pine used to survive. So I
Okay.
think this can also be one factor, or you can say that
But pines is resin, right?
resin.
That's resin.
But this bark is very thick.
Okay.
And this one, this oak, local people are dependent on the oak for this firewood.
Yeah.
And what you can see that if you go in the field, so they lop the trees.
Yes. Yes.
So in that lopping, so you have the means you are losing the flowers, more number of flowers or the seeds. So that could also be a reason that okay, they are not cutting the trees because of
Yeah, but still.
for forest department, but they are lopping. So there are many factors. So which one is more important? But still, we are talking about the climate. So climate is obviously it is very important.
Okay.
So
Pines may have zero filling nature. Zero filling.
Zero fill. Yes.
Zero fill.
Yes. Yes. Yeah. Yeah.
If we talk about agriculture, generally underneath a pine tree, not many plants they survive.
Yes.
because of the needles,
Not acidic.
acidic, yeah.
The pines are very acidic.
Yeah.
All the pines are very acidic. That's why
Yeah.
science is very complex.
Yeah. Could be.
And even I have seen the plantation. I was really surprised at one of the site I was in field. So there the forest department for planting the trees. So I just asked them that which tree you are planting. They said pine. I asked why. They don't know. Because and there that the actual forest was a oak forest.
Oh, that has been
Oak,
replaced. by-
rhododendron. So in that
Oh.
the pine was planted.
Oh, that's. Yeah.
There are some species of pine in one is the Pinus Roxburghi. I don't know everybody. Pinus Roxburghi, this one is in the tropical and subtropical region. And Pinus wallaceiana, that one is in the temperate region. You were talking about the Pinus wallaceiana, and both species work a little differently because the Pinus Roxburghi is at the lower elevation and it has a different, you see, the behavior, number one. My query, just a very simple query is that you talked about the tree line in Kashmir, it was 3,400 meters. How many years ago?
More than 400.
More than 400 years ago. And now it is around 3,800 meters or so.
No, it is before that.
Above that, yeah, 3,000, more than 3,800 meters. Yeah, so in 400 meters, this one has marched 400 to 600 meters. Isn't? Yeah. Now you have mentioned about the rhododendrons. What was the upper limit of that rhododendron?
Actually, it is to vary. Means the upper limit. Rhododendron in this Tumnath area and all, I have seen up to 3,600 meters and even above. The tree line by this ABs, that was at 3,400, between 3,450 around. But the rhododendron was more above. That is Campanulatum species. Campanulatum. So that was around 3,600, but in this Kashmir area and Dokrani area, it is going till 3,800, 3,900.
In the past. No. Yeah, because Kashmir is in the little higher latitude than Nepal, so you see. And again, when we talk about the rhododendron, there are several species of rhododendrons.
Yes.
The Campanulatum occurs around 5,000 plus.
Mhm.
Okay, and in exceptional case, it may be 5,400 meter or so. So it has definitely marched. So Campanulatum doesn't indicate the tree line actually. That one is shrubby.
That is shrubby.
Yeah,
Yes,
so
that is a shrubby.
usually so.
Pathological studies means why I said
Yeah.
the importance of that.
Yeah, so
Because contaminated
palynological study, can you distinct the species, which final species? Yeah. Okay, so.
Okay.
Okay, thank you, Dr. Parminder, for a wonderful presentation. So now we would like to, go to another speaker. So I would request Professor Tiwari, if he is still here and he's there. I can see him. So if he can try to, if you please unmute yourself and let's see if we are able to hear you now. Professor Tiwari. Yeah, I'm so sorry, sir. We are still unable to hear you. I think the problem exists still. So will you mind if we adjust your presentation tomorrow sometime? Is it okay? Okay, sir. Okay, thank you so much. And sorry for this inconvenience. So we may postpone his presentation for tomorrow. And we have another presentation. Maybe I'm not sure if Sitaram Ocha is here or not. He's there. So maybe I'll invite him for short presentation. So let me introduce him. So he's going to be our last presenter of this session. And he's a very talented young researcher with a promising future, Sitaram Ocha, who recently completed his master's degree in geology at Tribhuvan University, Kathmandu, Nepal in 2023. His training encompasses geological mapping, river mapping, landslide mapping, and watershed management, reflecting a strong foundation in earth sciences. Additionally, he is well trained in geographic information systems, showcasing his adeptness in utilizing various tools and software for geospatial analysis and data management. So I would like to invite Sitaram Ocha. Please share your presentation with us. Thank you so much.
Ma'am, I have sent my presentation to be an operator. Here, I got some problems in my mobile.
Yeah, we will do it from our side. Thank you.
Okay. Participants, guests, in this meeting. My topic is climate change from the perspective of geoscientists. We are talking about the climate change, and the Earth is nearly 4.6 billion years old. the climate in the earth is getting changed from the birth of the earth. Next slide. Please, next slide, ma'am. Next slide, please.
Yeah, we have some problem. It's still, we are trying to do it. Just few seconds. From Nepal. So let us have the panel discussion first, and then we come back to Mr. Oja's slide. Thank you so much. Okay, now. So this is fine. Is it okay? Now we can start. Yeah, so we start our panel discussion now. So Professor Muniappan, are you here? So our panelists are Professor R. Muniappan from the USA and Professor A.R. Dahal from Nepal. So may I request you to join online so we can have a discussion? Professor Muniappan, are you here? Yeah, Dr. Dahal is here. So maybe now we start the panel discussion. Okay, you can give the slides. You can start. We are online.
Okay, I'm trying to unmute. Finally, I got it unmuted. Yeah. Okay. Yeah, thanks.
Yeah, we welcome you, sir. And I think we will be able to connect you in a. Yeah.
I am connected. I try to unmute it. It is already unmuted. So I think, are you able to hear me?
Yes, just coming at you. Last.
Where is the seat? Here.
Just
So I'll take a few seconds to introduce Professor Rangaswamy N. Muniappan. He is a program director for IPM Innovation Lab, Center for International Research, Education and Development, Virginia Technology, Blackbird, USA, and is an entomologist who has specialized in biological control and integrated pest management research in the tropics for more than 35 years. His primary work experience has focused on the biological control of invasion weeds such as Chromolinia, Odorata, Lantana, Camerona, Coccinea grandis, and Mimosa diplotrechis. I'm not sure whether I'm pronunciating my pronunciation is so correct with this species name. So, and he also specializes in insect pest of tropical fruit and vegetable crops such as mealybugs, scale insects, whiteflies, caterpillars, and weevils. So Dr. Muniappan worked as the Associate Director of the Guam Agricultural Experiment Station for last 20 years. So I would like to invite you, sir, for this panel discussion.
Thank you.
Shall we start now? Professor Dahar?
Shall I proceed with, or you want to introduce the next participant too, or how do you proceed? Can you hear me?
Yeah,
Can you hear me?
yes.
Yes, we can hear you very well.
Shall I proceed?
Yes, sir.
Yes.
Okay. Thank you for the introduction. Yes, I have been working in the tropical region for the last almost half a century. And I have been participating in the agricultural crop protection area in Nepal since 2006. And around 2014, I had the opportunity to work with the scientists at the Tribhuvan University on climate change and biodiversity. In fact, in January 2017, the program organized an international conference on biodiversity and climate change at Kathmandu. In that conference, we had a participant from the political side. He was the ex-minister of agriculture from Nepal, and he came to the podium and he said, there is no climate change. You guys are wasting your time. So that's what he declared at that time. So at that time, I knew only two people who didn't believe in climate change. One was the ex-minister from Nepal, and the other one was the ex-president from the US, Mr. Donald Trump. So that was a very shocking experience in that conference. Well, anyway, that is a past story. Now, that kind of, statements are all over. Now, it is all accepted that climate change is real and we need to address. So in 2014, as I mentioned, I had a project in Nepal and I was working with Dr. Pramod Jha on that one. And also we were collaborating with the City University of New York. And there were some problems, so we tried to rewrite the project. Since it was around 2017 and 2018, even in the US, they said, no, in the proposal, you cannot use the term climate change. If that is there, they are not going to approve it. And so we have to kind of hide the climate change in the proposal, even though we wanted to do that work. Then around 2020, the whole thing changed. Then they said, you have to have climate change in your proposal, then only it will get approved. So these kind of political problems we encountered. And now it is okay. Climate change is real and we need to address it. I do have some slides, but I'm not sure I'll be able to project it. Let me try. Does it show?
Not yet.
Does it show?
Not yet, sir.
Okay, where do I click to get it going? Well, I think I will have a problem in sharing, so I will just continue with it without the slides. So, you know, we have been addressing mostly climate change and biodiversity. Climate change is affecting biodiversity. So in this project, we address 6 invasive species: Chromalina, Ageratina, Lantana, Mycenia, and Parthenium, and also Ipomia carnea. To see what happened to these introduced invasive species in Nepal, we ordered some of the satellite images, and also we collaborated with some computer scientists at the University of Virginia. And also we worked with the Tribhuvan University scientists in trying to do some ground level survey of these species. And then we try to overimpose these ground levels survey with the aerial images. Finally, we use the machine learning. Can you hear me? Or am I disconnected? Hello? Hello, can you hear me?
Yes, you are hearing me actually.
Yes, yes, yes. You are audible.
Yes, you are hearing me.
I try to, I'm sorry, I try to use my presentation, but I'm not able to get it.
So if you can share your presentation with us, we can play it from here.
Yes, part of the problem is it says it is too big to send it by email. So that's why I'm trying to. Okay, I won't try to use these slides, so I will just go ahead and with my presentation. So what I was trying to say is we have been working with the Tribhuvan University on trying to see the effect of climate change on the spread of the invasive species. There's 6 species we worked on were Chromalina, Ageratina, Lantana, Mycenia, Parthenium, and Ipomia. So we ordered some of the satellite imagery and also did some ground survey, tried to match the ground survey with the satellite images, and then trying to figure out what is the spread of these weeds in Nepal. So I think in our project, we were able to find that Chromalina, Ageratina, Lantana, Mycenia, and Parthenium have been spreading from 1990 to 2020 mostly from the western part of Nepal to eastern part of Nepal. And also because of the climate change, some of the species are moving northwards or higher up in the altitude. Ageratina is more of a subtropical species. So what it is doing is moving from subtropical to temperate area. Chromalina, Parthenium are more of tropical species. So they are moving from tropical to subtropical regions. So that's what basically we kind of came up with. And now we are trying to see whether further we can continue. Yes, our program already ended. Now we are trying to submit a proposal to National Science Foundation of US, trying to revive this program. That's where we are. So I will stop over there since I'm not able to project my slides. If there is any questions, I'll be happy to address.
So thank you so much, sir. Now I would just give a small introduction of Professor Khimraj Dahal. So once he talk his presentation, then maybe the session can be open for all the questions. So Professor Khimraj Dahal is a retired professor in agronomy of Institute of Agriculture and Animal Sciences, Tribhuvan University. He was responsible for teaching farming system and sustainable agriculture and organic agricultural courses at undergraduate level, along with the various courses related to crop production and management to postgraduate student and guiding them for master's thesis. He has published over 50 research papers in national and international journals on climatic changes, organic agricultural diversity, crop production, etc. Presently, he is associated with the South Asian Nitrogen Hub project as a principal investigator and coordinating partner, the UKRI GCRF UK. So I would like to invite Professor Khimraj Dahal for this panel discussion. Share your screen, please.
Share the screen here. Icon. Host disabled part. Mostly disabled. Here, got in
I would like to thank organizers for making me to present this small part of my knowledge. And my assumption here is that all of us know about climate change. Many people express their views with data, facts, and figures on climate change. I also will do something on that, but not much figures, but facts. Okay, let me start. Oh, it is not, slide is not moving. Net sorry, net sorry. Net sorry.
民族复兴伟业提供有力支撑。会议指出，党的18大以来，在党中央集中统一领导下，金融系统有力支撑经济社会发展大局，坚决打好防范化解重大风险攻坚战。
I'd like to explain a little bit about that. Earth system, human scientists, and climate change. These three themes are the core of today's meeting. Is Earth system. As you know, if we see the Earth as a system of interacting components, basically I would like to focus on more on biosphere, where we are living on and working in. And carbon and the green things, carbon and food webs, those are two basic things that our life exists upon. This biosphere, all of us who know about this, I don't have to much tell about that, but sun is the ultimate source of energy on the earth, and living plants are the factories to translate or transform that energy into biological one. And here we talk of climate, and those climatic factors and climates, the effect on the factors that we are working and we are doing or dealing with. Is climate system. It may take a little bit of time. Solar radiation, biosphere, atmosphere, hydrosphere, lithosphere, and interaction of all these components makes our earth and our living. Okay, then we go for it. It takes a bit of time. But in a way to understand climate, all these components, starting from direct solar radiation, all these acts on their own and makes the climatic system, and the winds. Actually, we are changing that system. Then many of us, those who talked already, had long discussion about climate change, different manifestations of changing climate. About that, I'm just making some points. These points are not known, not new, but already already known, and I'm just putting emphasize. The temperature change, hottest record, oxygen warming, smoke over decrease, sea level rise, shorter winter, so many things, so many. And lastly, rising extreme events such as heat, cold waves, and flash flood are very common to all of us. Then the causes of those changes in climate are the greenhouse gases. In gases, I don't want to go to the mechanism, but there are gases which trap the solar radiation, which otherwise would be either gone outside this atmosphere or cosmos, or do something inside, and now those gases trap the heat and we are heating the earth. Okay, then human activities, how those trapping agents or how those greenhouse gases are produced, these things I have just given the points. Basically, about 4 gases, for 6 gases are there, but basically from our food production point of view, carbon dioxide gas, methane, nitrous oxide are more prominent, which are responsible to trap the gases and produce greenhouse effect. Impact of climate change on agriculture. Actually, agriculture is the factory where we produce food, and the plants are the machines which produce glucose, then other products which are very important for living for all the creatures on earth. And that actually in cumulative term, all those productions and products are of our use, and those products are heavily impacted in the process, even in the from production to consumption are impacted by climate change. And ultimately the result is the effect of changing climate is food insecurity, which we are facing, as in Bangladesh, Dr. Chaudhary showed already. The impact of climate change, visual impact. being produced in newspapers, dry condition, no ropine, hard to eat. Okay, there is no monsoon rain, and these all are the region. This news is from newspaper. These very practical photo that we can see. There was rice about to harvest, and the harvest is rice. Later there was rain. He can't get that grain out of that, and he's weeping. Anger is there. Farmer simply crying, and he is not knowing what to do. This is effect of climate on agriculture. Apple farming in hill areas is vanishing. That's also a report from newspaper. Then Nepalese agriculture is very heterogeneous, starting from subsistence to semi-commercial to commercial. And there are many types of farming enterprises are coming, but still all those are being affected by climate change. But at the same time, agriculture also impacts the climate change. I put some points that how agriculture can impact climate change and being impacted nowadays, and rising global temperature through the emission of different gases, dust, pollutants. All those are the product of agricultural practices, and that affect climate change, especially methane gas from paddy field, agriculture, livestock from processing industries, and so from flowing dust pollution. And agriculture affects climate change. I have put some points. FAO has estimated that agriculture is responsible for 25% of carbon dioxide, 50% of methane, and more than 75% of nitrous oxide emitted annually. It is responsible for 70% of water withdrawal. That also impacts climate change, and either they reciprocate, both climate change impact that, and that impacts climate change. Consumption and use and tillage are primary cause of increased emission of carbon dioxide, while rice farming, livestock farming, and use of nitrogen fertilizers are primarily blamed for methane and nitrous oxide. The conversion of ecosystem to farmland is a major source of carbon dioxide, not only due to loss of plant biomass, but also through increased consumption of soil organic matter that also releases carbon. Okay, nitrogen. If we talk of nitrogen, nitrogen is the only element which feeds the world. But nitrogen itself does not feed anyone, but we have to convert that into the form that plant can take and give us food. Okay, nitrogen in nature, nitrogen is this cycle, nitrogen cycle is there. I'm not going to talk detail about that, but nitrogen in itself is non-reactive. Dinitrogen, that is nitrogen gas, it is inert, about 78% in the year. Many other forms of N are also present in the environment, including ammonia, ammonium, nitrate, nitrite, nitric oxide, and nitrous oxide. All those are reactive in our NR. Nitrous oxide is one of the most potential greenhouse gases, about 300 times more potential than CO2 to trap the heat. In healthy soils with high oxygen content, bacteria produce nitrate from ammonium in a process called nitrification, and in doing so, they also create nitrous oxide. Thus, from agriculture field, there is a main mechanism that nitrous oxide is emitted. Nitrous oxide concentration has increased from 270 ppb during pre-industrial times to 328.9 ppb. Yesterday, Dr. Paulo from Brazil was he gave data that 120% has increased. The nitrous oxide has increased in the range of 120%, he told. I just noted that. And nitrogen fertilizer, generally we, in high temperature and high pressure, from nitrogen from air, we take nitrogen and hydrogen, in compressor we put ammonia. That is the basic form of nitrogen that we fix from air, and that is in turn goes to the fertilizer. Okay, well, I talked nitrous oxide is heavily potential greenhouse gas, but from where does that come? It is US data. Every particular fertilizer soil and waste accounts for over 3/4 of US nitrous oxide. In Nepal, we don't have that data, as Dr. Madan also told in his presentation. We seriously lack the data. But if we see this nitrous oxide emission from other countries or from these countries. Anyway, but most important is 74%. During managing agricultural soil, 70%, 74% of nitrous oxide is emitted. That is data. Then what then? Nitrogen is important. We have to do that. We have to manage the nitrogen in the way that nitrous oxide can be emitted or that emission can be minimized. How can we do that? Use corporation with legumes and local crops, so that we have to use less and less nitrogen. Then use of organic matter for soil quality and health. Healthy soil is always good and emission is less. And also, when we use organic manure, at that case, the releasing of nutrients is slow, nitrogen is slow, and thereby less chance of nitrous oxide emission. 4R principle from 4R principle while using nitrogen fertilizer, that is right time, right fertilizer, right place, right mode of application. In that case, if we use those things rightly, then there is a low chance of nitrous oxide emission. Use nitrogen fertilizer only when it is critically needed. Generally, our farmers, they use nitrogen fertilizer wherever and whenever they want, and they get, because it is very difficult to get. Even when they get, they use. It's a wrong way of using doing with nitrogen fertilizer. Use slow releasing fertilizers, for example, neem-coated urea. Use of nitrification inhibitors, there are already, those chemicals are already there, but if possible. Then use of leaf color chart and MS formula. Those models, those techniques are just to see when and how much to nitrogen to give to the plant, so that there is less chemical reaction or chemical transformation from ammonia to nitrate. Then use of urea super granules are already in production and they are in use. Then I'm not going to, we don't have time that much. Okay. Then if we talk of agriculture and climate change, how we deal with climate change, taking agriculture together, that is climate smart agriculture is one of the aspects. I'm not going to discuss much. But the main focus of that system of agriculture is mitigation, adaptation, production, all those three. But it is not always, it's not always instrumental. It may depend upon the place. That's why I'm not going to detail. But generally, the adaptation and mitigation in agriculture comes through climate change awareness first and local specificity. What is the scenario and what climate does and how to cope with that. Disaster conversion agriculture with research conversion technologies, or farming, urban and agriculture, local food production and conversion system, integration of local resources in watershed management, decision extension on climate smart agriculture, federal government policy. All these are very basic notions, very basic important points when we talk about climate change and agriculture. I am finishing almost. Now, since we are talking about young scientists, I have 30 tips for young scientists. First, observation. Whatever you want to do, please observe first. Then internalize, feel the problem. Then conceptualize. Whatever you think, when you observe things, when you internalize, how you digest, then only you can feel something about that. Then reflection. Then you reflect whatever you want to do, what is your opinion, talk to others. Then imagination. Okay, then our ultimate result will be this. I want to have this one. That's my hypothesis. That imagination is very important. Then formulation. After imagination, then you are ready to work. Then just design what type of thing you want to do, what research you want to do. Then research is important, experimentation. Then after that, interpretation. You did research, you have data, how to interpret. That's very important. Then verification, whether hypothesis is tested and whether you are right in right position, or whether that your result is in online with others also, that you have to verify. Then localization. Whenever you do research, whenever your research verified result, then whether you always you feel whether this fits my local condition, because I am always things should be started from local so that goes to global. Otherwise all of the projects and things nowadays they come from up down, which are not very useful. Then implementation, then you implement that thing. Then evaluation, you evaluate whatever you have done, I don't know whether you are happy or not, then continuous with curiosity and devotion. Okay, these are the 13 tips, my tips to young scientists. Then thank you very much for your kind patience.
Thank you so much, Professor Dahal. Now this session is open for the discussion. If we have any sort of questions from any of our speakers since morning to now, so we can have the discussion. Any questions in the chat box? Do we have any questions from the audience presented here?
Shall I address one of the comment that came in the chat box?
Yes, please.
You know, the question is why there is a movement of these invasive species from south to north and east to west, I think. Well, most of these invasive species that I mentioned, that Chromalina, Parthenium, Ageratina, they have moved from eastern part of India into Nepal. So what is happening, it established in the east Nepal first. Now they are migrating towards west. Another thing, because of the climate change, what is happening as the higher altitudes are warming up, so some of these species like the Parthenium that is more adapted to tropical condition is moving northwards to the subtropical conditions. Similarly, Ageratina that is adapted to subtropical condition is moving more on the temperate conditions. So that is the kind of movement we are seeing in Nepal.
Sir, do you have any message for the young scientists who are present in our meeting today?
Well, you know, in our project that we worked with Dr. Pramod Jha and other colleagues from Tribhuvan University, botany department, we were able to train almost about 25 graduate students. I think 20 of them in master's program and 5 in PhD program. So, but that project came to an end last year. So we are further looking for additional support from National Science Foundation or other areas. If we are successful, we would be able to implement or continue this project in Nepal. If that happens, there'll be good opportunity for young scientists or young students to participate in this program. In this program, as I mentioned, we have been working with the computer scientists from the University of Virginia, and they helped us in identifying these invasive species in the satellite imagery. And using that satellite imagery, we were able to trace the spread of these species from 1990 to 2020, about the last 30 years. We have seen how these species have spread within Nepal. So there's good opportunity to work on it. We are also trying to work on how to manage this space, invasive species. Well, we can do mechanically. That is a very tedious job and it is not very practical. The other one is use of chemicals that is expensive and also environmentally not that safe. So we have been trying to use some natural enemies for controlling these weeds. But Nepal is not prepared or at this time to take up that kind of work. So what is happening is some of the natural enemies introduced in India for controlling these invasive species, they are moving fortuitously into Nepal. So far we have identified about 5 such agents have already moved in and trying to encourage or spread those agents in Nepal so that we could suppress these weeds. But more work need to be done, and there is, the government of Nepal need to get involved in it. I will stop it over there. If there are any questions, I'll be happy to address.
Thank you so much, sir. And I hope all the youngsters would be getting benefited because they have a lot of opportunities to work in the scientific fields, as Professor said. So are there any questions from the audience or participants? And if we do not have any questions, so maybe we close the session here. And I request Mr. Ojha that we can accommodate his presentation for tomorrow. We are running short of time today. It's already 6:15.
I have one doubt on this species.
Okay. Sir, one more question for you from Dr. Parmendra Ranhotra.
Sir, I have one doubt. Means these species are migrating or spreading?
Sorry, could you please repeat?
These species are migrating or spreading?
Well, primarily they are spreading, and mostly aided by the humans to a certain extent, because like Parthenium, if some road making machines or bulldozers or tractors that are used in one place, if they move it to a new place, usually the seeds get carried through the equipment. That is one way. And the other one is some of these weeds are spread by wind, rain, and other. So several factors are involved in it. So once if they establish, they start moving by the different means. Yeah.
Thank you so much, sir. So it's your okay. Okay, sir. Thank you so much for your time and such a wonderful presentation and the information you have shared with the young scientist, one researcher coming up. So I would like to thank both our panelists and would like to close the session here. And Mr. Ojha, again, it's our apology. Please accept it, and we will try to adjust your presentation tomorrow, and I'll inform you well in advance. So, and Professor Tiwari also, we will be giving you time tomorrow for your presentation, and then we will close this session here. And tomorrow morning, we will meet again at 2 o'clock Nepali Standard Time. Thank you so much. I really thank all the participants for today's. Thank you so much.